Occult Chemistry. Chapter 1. A Preliminary Survey. The deep interest and importance of the research which this book describes will best be appreciated if introduced by an account of the circumstances out of which it arose. The first edition, consisting mainly of articles reprinted from the Theosophist, dealt at once with the later phases of the research in a way which, though intelligible to the occult student, must have been rather bewildering to the ordinary reader. These later phases, however, endow the earlier results with a significance that in the beginning could only be vaguely conjectured. I am the better entitled to perform the task that has been assigned to me, that of preparing the present edition, by reason of the fact that it was in my presence, and at my instigation, that the first efforts were made to penetrate the mystery previously enshrouding the ultimate molecule of matter. I remember the occasion vividly. Mr. Leadbeater was then staying at my house, and his clairvoyant faculties were frequently exercised for the benefit of myself, my wife, and the theosophical friends around us. I had discovered that these faculties, exercised in the appropriate direction, were ultramicroscopic in their power. It occurred to me once to ask Mr. Leadbeater if he thought he could actually see a molecule of physical matter. He was quite willing to try, and I suggested a molecule of gold as one which he might try to observe. He made the appropriate effort and emerged from it, saying the molecule in question was far too elaborate a structure to be described. It evidently consisted of an enormous number of some smaller atoms, quite too many to count, quite too complicated in their arrangement to be comprehended. It struck me at once that this might be due to the fact that gold was a heavy metal of high atomic weight, and that observation might be more successful if directed to a body of low atomic weight, so I suggested an atom of hydrogen as possibly more manageable. Mr. Leadbeater accepted the suggestion and tried again. This time he found the atom of hydrogen to be far simpler than the other, so that the minor atoms constituting the hydrogen atom were countable. They were arranged on a definite plan, which will be rendered intelligible by diagrams later on, and were 18 in number. We little realized at the moment the enormous significance of this discovery, made in the year 1895, long before the discovery of radium enabled physicists of the ordinary type to improve their acquaintance with the electron. Whatever name is given to that minute body, it is recognized now by ordinary science as well as by occult observation as the fundamental unit of physical matter. To that extent, ordinary science has overtaken the occult research I am dealing with, but that research rapidly carried the occult student into regions of knowledge whither, it is perfectly certain, the ordinary physicist must follow him at no distant date. The research once started in the way I have described was seen to be intensely interesting. Mrs. Besant almost immediately cooperated with Mr. Leadbeater in its further progress. Encouraged by the success with hydrogen, the two important gases, oxygen and nitrogen, were examined. They proved to be rather more difficult to deal with than hydrogen, but were manageable. Oxygen was found to consist of 290 minor atoms and nitrogen of 261. Their grouping will be described later on. The interest and importance of the whole subject will best be appreciated by a rough indication of the results first attained. The reader will then have more patience in following the intricacies of the later discoveries. The figures just quoted were soon perceived to have a possible significance. The atomic weight of oxygen is commonly taken as 16. That is to say, an atom of oxygen is 16 times heavier than an atom of hydrogen. In this way, all through the table of atomic weights, hydrogen is taken as unity without any attempt being made to estimate its absolute weight. But now with the atom of hydrogen dissected, so to speak, and found to consist of 18 somethings, while the atom of oxygen consisted of 290 of the same things, the 16-to-1 relationship reappears. 290 divided by 18 gives us 16 and a minute decimal fraction. Again, the nitrogen number divided by 18 gives us 14 and a minute fraction as the result, and that is the accepted atomic weight of nitrogen. This gave us a glimpse of a principle that might run all through the table of atomic weights. For reasons having to do with other work, it was impossible for the authors of this book to carry on the research further at the time it was begun. The results already sketched were published as an article in the magazine then called Lucifer in November 1895, and reprinted as a separate pamphlet bearing the title Occult Chemistry, a pamphlet the surviving copies of which will one day be a recognized vindication of the method that will at some time in the future be generally applied to the investigation of nature's mysteries. For the later research which this volume deals with does establish the principle with a force that can hardly be resisted by any fair-minded reader. With patience and industry, the authors being assisted in the counting in a way that will be described, and the method adopted involved a check upon the accuracy of the counting. The minor atoms of almost all the known chemical elements, as they are commonly called, were counted and found to bear the same relation to their atomic weights as had been suggested by the cases of oxygen and nitrogen. This result throws back complete proof on the original estimate of the number of minor atoms in hydrogen, a figure which ordinary research has so far entirely failed to determine. The guesses have been widely various, from unity to many hundreds, but unacquainted with the clairvoyant method, the ordinary physicist has no means of reaching the actual state of the facts. Before going on with the details of the later research, some very important discoveries arising from the early work must first be explained. As I have already said, clairvoyant faculty of the appropriate order directed to the minute phenomena of nature is practically infinite in its range. Not content with estimating the number of minor atoms in physical molecules, the authors proceeded to examine the minor atoms individually. They were found to be themselves elaborately complicated structures, which, in this preliminary survey of the whole subject, I will not stop to explain. Full explanation will be found later on. And they are composed of atoms belonging to an ultra-physical realm of nature with which the occultist has long been familiar and describes as the astral plane. Some rather pedantic critics have found fault with the term, as the plane in question is of course really a sphere entirely surrounding the physical globe, but as all occultists understand, the word plane simply signifies a condition of nature. Each condition, and there are many more than the two under consideration, blends with its neighbor via atomic structure. Thus the atoms of the astral plane in combination give rise to the finest variety of physical matter, the ether of space, which is not homogeneous but really atomic in its character, and the minute atoms of which physical molecules are composed are atoms of ether, etheric atoms, as we have now learned to call them. Many physicists, though not all, will resent the idea of treating the ether of space as atomic, but at all events, the occultist has the satisfaction of knowing that the great Russian chemist, Mendeleev, preferred the atomic theory. In Sir William Tilden's recent book entitled Chemical Discovery and Invention in the 20th Century, I read that Mendeleev, disregarding conventional views, supposed the ether to have a molecular or atomic structure, and in time all physicists must come to recognize that the electron is not, as so many suppose at present, an atom of electricity, but an atom of ether carrying a definite unit charge of electricity. Long before the discovery of radium led to the recognition of the electron as the common constituent of all the bodies previously described as chemical elements, the minute particles of matter in question had been identified with the cathode rays observed in Sir William Crookes' vacuum tubes. When an electric current is passed through a tube from which the air or other gas it may contain has been almost entirely exhausted, a luminous glow pervades the tube, manifestly emanating from the cathode or negative pole of the circuit. This effect was studied by Sir William Crookes very profoundly. Among other characteristics, it was found that if a minute windmill was set up in the tube before it was exhausted, the cathode ray caused the vanes to revolve, thus suggesting the idea that they consisted of actual particles driven against the vanes, the ray being thus evidently something more than a mere luminous effect. Here was a mechanical energy to be explained, and at the first glance it seemed difficult to reconcile the facts observed with the idea creeping into favor, that the particles, already invested with the name electron, were atoms of electricity pure and simple. Electricity was found, or certain eminent physicists thought they had found, that electricity per se had inertia. So the windmills in the Crookes vacuum tubes was supposed to be moved by the impact of electric atoms. Then, in the progress of ordinary research, the discovery of radium by Madame Curie in the year 1902 put an entirely new face upon the subject of electrons. The beta particles emanating from radium were soon identified with the electrons of the cathode ray. Then followed the discovery that the gas helium, previously treated as a separate element, evolved itself as one consequence of the disintegration of radium. Transmutation, till then laughed at as a superstition of the alchemist, passed quietly into the region of accepted natural phenomena, and the chemical elements were seen to be bodies built up of electrons in varying number and probably in varying arrangements. So at last ordinary science had reached one important result of the occult research carried on 7 years earlier. It has not yet reached the finer results of the occult research, the structure of the hydrogen atom with its 18 etheric atoms, and the way in which the atomic weights of all elements are explained by the number of etheric atoms entering into their constitution. The ether of space, though defying instrumental examination, comes within scope of the clairvoyant faculty, and profoundly interesting discoveries were made during what I have called the early research in connection with that branch of the inquiry. Etheric atoms combine to form molecules in many different ways, but combinations involving fewer atoms than the 18 which give rise to hydrogen make no impression on the physical senses nor on physical instruments of research. They give rise to varieties of molecular ether, the comprehension of which begins to illuminate realms of natural mystery as yet entirely untrodden by the ordinary physicist. Combinations below 18 in number give rise to 3 varieties of molecular ether, the functions of which, when they come to be more fully studied, will constitute a department of natural knowledge on the threshold of which we already stand. Some day we may perhaps be presented with a volume on occult physics as important in its way as the present dissertation on occult chemistry. Chapter 2. Details of the early research. The article detailing the results of the research carried on in the year 1895, see the November issue for that year of the magazine, then called Lucifer, began with some general remarks about the clairvoyant faculty already discussed in the preceding chapter. The original record then goes on as follows. The physical world is regarded as being composed of between 60 and 70 chemical elements, aggregated into an infinite variety of combinations. These combinations fall under the 3 main heads of solids, liquids, and gases, the recognized substates of physical matter, with the theoretical ether scarcely admitted as material. Ether, to the scientist, is not a substate or even a state of matter, but is a something apart by itself. It would not be allowed that gold could be raised to the etheric condition as it might be to the liquid and gaseous, whereas the occultist knows that the gaseous is succeeded by the etheric, as the solid is succeeded by the liquid, and he knows also that the word ether covers 4 substates as distinct from each other as are the solids, liquids, and gases, and that all chemical elements have their 4 etheric substates, the highest being common to all, and consisting of the ultimate physical atoms to which all elements are finally reducible. The chemical atom is regarded as the ultimate particle of any element, and is supposed to be indivisible and unable to exist in a free state. Mr. Crookes' researches have led the more advanced chemists to regard the atoms as compound, as a more or less complex aggregation of protyl. To astral vision, ether is a visible thing, and is seen permeating all substances and encircling every particle. A solid body is a body composed of a vast number of particles suspended in ether, each vibrating backwards and forwards in a particular field at a high rate of velocity. The particles are attracted towards each other more strongly than they are attracted by external influences, and they cohere or maintain towards each other a definite relation in space. Closer examination shows that the ether is not homogeneous, but consists of particles of numerous kinds, differing in the aggregations of the minute bodies composing them, and a careful and more detailed method of analysis reveals that it has 4 distinct degrees, giving us, with the solid, liquid, and gaseous, 7 instead of 4 substates of matter in the physical world. These 4 etheric substates will be best understood if the method be explained by which they were studied. This method consisted of taking what is called an atom of gas and breaking it up time after time until what proved to be the ultimate physical atom was reached, the breaking up of this last resulting in the production of astral and no longer physical matter. Substates of matter for hydrogen, oxygen, and nitrogen. It is, of course, impossible to convey by words the clear conceptions that are gained by direct vision of the objects of study, and the accompanying diagram, cleverly drawn from the description given by the investigators, is offered as a substitute, however poor, for the lacking vision of the readers. The horizontal lines separate from each other the 7 substates of matter: solid, liquid, gas, ether 4, ether 3, ether 2, ether 1. On the gas level are represented 3 chemical atoms, one of hydrogen, one of oxygen, one of nitrogen. The successive changes undergone by each chemical atom are shown in the compartments vertically above it, the left-hand column showing the breaking up of the hydrogen atom, the middle column that of the oxygen atom, the right-hand column that of the nitrogen atom. The ultimate physical atom is marked A and is drawn only once, although it is the same throughout. The numbers 18, 290 and are the numbers of the ultimate physical atoms found to exist in a chemical atom. The dots indicate the lines along which force is observed to be playing, and the arrowheads show the direction of the force. No attempt has been made to show this below E2, except in the case of the hydrogen. The letters given are intended to help the reader to trace upwards any special body. Thus D in the oxygen chemical atom on the gas level may be found again on E4, E3, and E2. It must be remembered that the bodies shown diagrammatically in no way indicate relative size. As a body is raised from one substate to the one immediately above it, it is enormously magnified for the purpose of investigation, and the ultimate atom on E1 is represented by the dot A on the gaseous level. The first chemical atom selected for this examination was an atom of hydrogen. On looking carefully at it, it was seen to consist of 6 small bodies contained in an egg-like form. It rotated with great rapidity on its own axis, vibrating at the same time, and the internal bodies performed similar gyrations. The whole atom spins and quivers and has to be steadied before exact observation is possible. The 6 little bodies are arranged in 2 sets of 3, forming 2 triangles that are not interchangeable, but are related to each other as object and image. The lines in the diagram of it on the gaseous subplane are not lines of force, but show the 2 triangles. On a plane surface, the interpenetration of the triangles cannot be clearly indicated. Further, the 6 bodies are not all alike. They each contain 3 smaller bodies, each of these being an ultimate physical atom, but in 2 of them the 3 atoms are arranged in a line, while in the remaining 4 they are arranged in a triangle. The wall of the limiting spheroid, in which the bodies are enclosed being composed of the matter of the third, or gaseous, kind, drops away when the gaseous atom is raised to the next level, and the 6 bodies are set free. They at once rearrange themselves in 2 triangles, each enclosed by a limiting sphere. The 2 marked B in the diagram unite with one of those marked B to form a body which shows a positive character, the remaining 3 forming a second body negative in type. These form the hydrogen particles of the lowest plane of ether, marked E4, ether 4, on the diagram. On raising these further, they undergo another disintegration, losing their limiting walls. The positive body of E4, on losing its wall, becomes 2 bodies, one consisting of the 2 particles, marked B, distinguishable by the linear arrangement of the contained ultimate atoms, enclosed in a wall, and the other being the third body enclosed in E4 and now set free. The negative body of E4 similarly, on losing its wall, becomes 2 bodies, one consisting of the 2 particles marked B, and the second, the remaining body, being set free. These free bodies do not remain on E3, but pass immediately to E2, leaving the positive and negative bodies, each containing 2 particles, as the representatives of hydrogen on E3. On taking these bodies, a step higher their wall disappears, and the internal bodies are set free, those containing the atoms arranged linearly being positive, and those with the triangular arrangement being negative. These 2 forms represent hydrogen on E2, but similar bodies of this state of matter are found entering into other combinations, as may be seen by referring to F on E2 of nitrogen. On raising these bodies yet one step further, the falling away of the walls sets the contained atoms free, and we reach the ultimate physical atom, the matter of E1. The disintegration of this sets free particles of astral matter, so that we have reached in this the limit of physical matter. The theosophical reader will notice with interest that we can thus observe 7 distinct substates of physical matter, and no more. The ultimate atom, which is the same in all the observed cases, is an exceedingly complex body, and only its main characteristics are given in the diagram. It is composed entirely of spirals, the spiral being in its turn composed of spiral A, and these again of minuter spiral A. A fairly accurate drawing is given in Babbitt's Principles of Light and Color, p. 102. The illustrations there given of atomic combinations are entirely wrong and misleading, but if the stovepipe run through the center of the single atom be removed, the picture may be taken as correct, and will give some idea of the complexity of this fundamental unit of the physical universe. Turning to the force side of the atom and its combinations, we observe that force pours in the heart-shaped depression at the top of the atom and issues from the point, and is changed in character by its passage. Further, force rushes through every spiral and every spirilla, and the changing shades of color that flash out from the rapidly revolving and vibrating atom depend on the several activities of the spirals. Sometimes one, sometimes another, is thrown into more energetic action, and with the change of activity from one spiral to another the color changes. The building of a gaseous atom of hydrogen may be traced downward from E1, and as stated above, the lines given in the diagram are intended to indicate the play of the forces which bring about the several combinations. Speaking generally, positive bodies are marked by their contained atoms setting their points towards each other and the center of their combination, and repelling each other outwards. Negative bodies are marked by the heart-shaped depressions being turned inwards, and by a tendency to move towards each other instead of away. Every combination begins by a welling up of force at a center, which is to form the center of the combination. In the first positive hydrogen combination, E2, an atom revolving at right angles to the plane of the paper and also revolving on its own axis, forms the center, and force, rushing out at its lower point, rushes in at the depressions of 2 other atoms, which then set themselves with their points to the center. The lines are shown in +B right-hand figure. The left-hand figure indicates the revolution of the atoms each by itself. As this atomic triad whirls round, it clears itself a space, pressing back the undifferentiated matter of the plane and making to itself a whirling wall of this matter, thus taking the first step towards building up the chemical hydrogen atom. A negative atomic triad is similarly formed, the 3 atoms being symmetrically arranged round the center of outwelling force. These atomic triads then combine, 2 of the linear arrangement being attracted to each other, and 2 of the triangular, force again welling up and forming a center and acting on the triads as on a single atom, and a limiting wall being again formed as the combination revolves round its center. The next stage is produced by each of these combinations on E3, attracting to itself a 3rd atomic triad of the triangular type from E2 by the setting up of a new center of upwelling force, following the lines traced in the combinations of E4. 2 of these uniting, and their triangles interpenetrating, the chemical atom is formed, and we find it to contain in all 18 ultimate physical atoms. The next substance investigated was oxygen, a far more complicated and puzzling body. The difficulties of observation were very much increased by the extraordinary activity shown by this element and the dazzling brilliancy of some of its constituents. The gaseous atom is an ovoid body, within which a spirally coiled snake-like body revolves at a high velocity, 5 brilliant points of light shining on the coils. The snake appears to be a solid rounded body, but on raising the atom to E4, the snake splits lengthwise into 2 waved bodies, and it is seen that the appearance of solidity is due to the fact that these spin round a common axis in opposite directions, and so present a continuous surface, as a ring of fire can be made by whirling a lighted stick. The brilliant bodies seen in the atom are on the crests of the waves in the positive snake, and in the hollows in the negative one. The snake itself consists of small bead-like bodies, 11 of which interpose between the larger brilliant spots. On raising these bodies to E3, the snakes break up, each bright spot carrying with it 6 beads on one side and 5 on the other. These twist and writhe about still with the same extraordinary activity, reminding one of fireflies stimulated to wild gyrations. It can be seen that the larger brilliant bodies each enclose 7 ultimate atoms, while the beads each enclose 2. Each bright spot with its 11 beads is enclosed in a wall accidentally omitted in the diagram. On the next stage, E2, the fragments of the snakes break up into their constituent parts, the positive and negative bodies marked D and D, showing a difference of arrangement of the atoms contained in them. These again finally disintegrate, setting free the ultimate physical atoms, identical with those obtained from hydrogen. The number of ultimate atoms contained in the gaseous atom of oxygen is 290, made up as follows. 2 in each bead, of which there are 110. 7 in each bright spot, of which there are 10. 2 plus 70 equals 290. When the observers had worked out this, they compared it with the number of ultimate atoms in hydrogen. 290/18 equals 16, 11 plus. The respective number of ultimate atoms contained in a chemical atom of these two bodies are thus seen to closely correspond with their accepted weight numbers. It may be said in passing that a chemical atom of ozone appears as an oblate spheroid, with the contained spiral much compressed and widened in the center. The spiral consists of 3 snakes, 1 positive and 2 negative, formed in a single revolving body. On raising the chemical atom to the next plane, the snake divides into 3, each being enclosed in its own egg. The chemical atom of nitrogen was the third selected by the students for examination, as it seemed comparatively quiet in contrast with the ever-excited oxygen. It proved, however, to be the most complicated of all in its internal arrangements, and its quiet was therefore a little deceptive. Most prominent was the balloon-shaped body in the middle, with 6 smaller bodies in 2 horizontal rows and 1 large egg-shaped one in the midst, contained in it. Some chemical atoms were seen in which the internal arrangement of these contained bodies was changed, and the 2 horizontal rows became vertical. This change seemed to be connected with a greater activity of the whole body, but the observations on this head are too incomplete to be reliable. The balloon-shaped body is positive and is apparently drawn downwards towards the negative egg-shaped body below it, containing 7 smaller particles. In addition to these large bodies, 4 small ones are seen, 2 positive and 2 negative, the positive containing 5 and the negative 4 minuter spots. On raising the gaseous atom to E4, the falling away of the wall sets free the 6 contained bodies and both the balloon and the egg round themselves, apparently with the removal of their propinquity, as though they had exercised over each other some attractive influence. The smaller bodies within the egg, marked Q on E4, are not on one plane, and those within N and O form respectively square-based and triangular-based pyramids. On raising all these bodies to E3, we find the walls fall away as usual, and the contents of each cell are set free. P of E4 contains 6 small bodies marked K, and these are shown in K of E3 as containing each 7 little bodies, marked E, each of which has within it 2 ultimate atoms. The long form of PE4, marked L, appears as the long form L on E3, and this has 3 pairs of smaller bodies within it, F, G, and H, containing respectively 3, 4, and 6 ultimate atoms. Q of E4, with its 7 contained particles, M, has 3 particles M on E3, each showing 3 ultimate atoms within them. E from N of E4 becomes I of E3, with contained bodies E, showing 2 ultimate atoms in each, while E from O of E4 becomes J of E3, each having 3 smaller bodies within it, E, with 2 ultimate atoms in each. On E2, the arrangement of these ultimate atoms is shown, and the pairs F, G, and H are seen with the lines of force indicated. The triads in F, from M of E3, are similarly shown, and the duads in E and E, from I and J of E3, are given in the same way. When all these bodies are raised to E1, the ultimate physical atoms are set free, identical, of course, with that previously described. Reckoning up the number of ultimate physical atoms in a chemical atom of nitrogen, we find they amount to 261, thus divided. 62 plus bodies with 2 ultimate atoms. 62 equals 124. 24, 2, and 24 equals 48. 21, 3, 21 equals 63. 2 plus 3, 2 equals 6. 2 plus 4, 2 equals 8. 2 plus 4, 2 equals 12. This again approaches closely the weight number assigned to nitrogen. 261/18 equals 14, 44 plus. This is interesting as checking the observations, for weight numbers are arrived at in so very different a fashion, and especially in the case of nitrogen, the approximation is noteworthy from the complexity of the bodies which yield the number on analysis. Some other observations were made which went to show that, as weight numbers increased, there was a corresponding increase in the number of bodies discerned within the chemical atom. Thus, gold showed 47 contained bodies, but these observations need repetition and checking. Investigation of a molecule of water revealed the presence of 12 bodies from hydrogen and the characteristic snake of oxygen, the encircling walls of the chemical atoms being broken away. But here again, further observations are necessary to substantiate details. The present paper is only offered as a suggestion of an inviting line of research, promising interesting results of a scientific character. The observations recorded have been repeated several times and are not the work of a single investigator, and they are believed to be correct so far as they go. The Platonic solids. Some of our readers may be glad to have a drawing of the Platonic solids, since they play so large a part in the building up of elements. The regular solids are 5, and 5 only, in each. The 5 Platonic solids. It will be seen that the tetrahedron is the fundamental form, the three-sided pyramid on a triangular base, i.e., a solid figure formed from 4 triangles. 2 of these generate the cube and the octahedron. 5 of these generate the dodecahedron and the icosahedron. The rhombic dodecahedron is not regular, for though the lines and surfaces are equal, the angles are not. Notes. Mr. C. Jinarajadasa writes, the asterisk put before metagon in the list of elements should be omitted, for metagon had been discovered by Sir William Ramsay and Mr. Travers at the same time as neon. See Proceedings of the Royal Society, Vol. LZIP 411, and therefore before it was observed clairvoyantly. It is not, however, given in the latest list of elements in the report of November 13, 1907, of the International Atomic Weights Commission, so it would seem as though it were not yet fully recognized. Neon was discovered in 1898 by Ramsay and Travers, and the weight given to it was 22. This almost corresponds with our weight for metaneon, 22. 33. The latest weight given to neon is 20, and that corresponds within 1/10 to our weight, 19.9. From this, it would seem that neon was examined in the later investigations and metaneon in the earlier. He says further, on a probable 4th interperiodic group. Thinking over the diagrams, it seemed to me likely that a 4th group exists, coming on the paramagnetic side, directly under iron, cobalt, nickel, just one complete swing of the pendulum after rhodium, ruthenium, palladium. This would make 4 interperiodic groups, and they would come also periodically in the table too. I took the diagram for osmium, and in a bar postulated only 3 columns for the first element of the new groups, i.e., 1 column less than in osmium. This would make 183 atoms in a bar. The new group then would follow in a bar, 183, 185, 187. Here I found to my surprise that the third postulated group would have a remarkable relation to O's, pt. Thus, O's 245 in a bar, less 60 equals 185. 247 less 60 equals 187. PT 249 less 60 equals 189. But strange to say also. Ruthenium bar 132 less 60 72. Rhodium less 60 74. Palladium less 60 76. But 72, 74, 76 are iron, cobalt, and nickel. So there does probably exist a new group with bars 183, 185, 187, 189 with atomic weights. 10 equals bar 185, atoms 2590, WT 143, 3. Y equals 187, 2618, WT 145, 4. Z equals 189, 2646, WT 147, 0. They come probably among the rare earths. Probably also neodymium and praseodymium are two of them, for their weights are 143, 6, 145. Chapter 3. The later researches. The first difficulty that faced us was the identification of the forms seen on focusing the sight on gases. We could only proceed tentatively. Thus, a very common form in the air had a sort of dumbbell shape, see plate I. We examined this, comparing our rough sketches, and counted its atoms. These, divided by 18, the number of ultimate atoms in hydrogen, gave us 23, 22 as atomic weight, and this offered the presumption that it was sodium. We then took various substances, common salt, etc., in which we knew sodium was present, and found the dumbbell form in all. In other cases, we took small fragments of metals, as iron, tin, zinc, silver, gold. In others, again, pieces of ore, mineral waters, etc., etc., and for the rarest substances, Mr. Leadbeater visited a mineralogical museum. In all, 57 chemical elements were examined, out of the 78 recognized by modern chemistry. In addition to these, we found chemical waifs, an unrecognized stranger between hydrogen and helium, which we named occultum for purposes of reference, and varieties of one element, which we named chalon and metachalon, between xenon and osmium. We also found varieties of 4 recognized elements and prefixed meta to the name of each, and a second form of platinum that we named PT. Thus, we have tabulated in a chemical elements or chemical atoms, completing 3 of Sir William Crookes' lemniscates, sufficient for some amount of generalization. Plate I sodium, plate I sodium. In counting the number of ultimate atoms in a chemical elemental atom, we did not count them throughout, one by one. When, for instance, we counted up the ultimate atoms in sodium, we dictated the number in each convenient group to Mr. Jinarajadasa, and he multiplied out the total, divided by 18, and announced the result. Thus, sodium C plate I is composed of an upper part, divisible into a globe and funnels, a lower part similarly divided, and a connecting rod. We counted the number in the upper part, globe 10, the number in 2 or 3 of the funnels, each 16, the number of funnels 12, the same for the lower part, in the connecting rod 14. Mr. Jinarajadasa reckoned 10 plus 16 equals 202, hence 202 plus 202 plus 14 equals 418, divided by 18 equals 23, 22 recurring. By this method, we guarded our counting from any prepossession, as it was impossible for us to know how the various numbers would result on addition, multiplication, and division, and the exciting moment came when we waited to see if our results endorsed or approached any accepted weight. In the heavier elements, such as gold, with 3546 atoms, it would have been impossible to count each atom without quite unnecessary waste of time when making a preliminary investigation. Later, it may be worthwhile to count each division separately, as in some we noticed that 2 groups, at first sight alike, differed by 1 or 2 atoms, and some very slight errors may, in this way, have crept into our calculations. In the following table is a list of the chemical elements examined. The first column gives the names, the asterisk affixed to some indicating that they have not yet been discovered by orthodox chemistry. The second column gives the number of ultimate physical atoms contained in one chemical atom of the element concerned. The third column gives the weight as compared with hydrogen, taken as 18, and this is obtained by dividing the calculated number of ultimate atoms by 18. The fourth column gives the recognized weight number, mostly according to the latest list of atomic weights, the International List of 1905, given in Erdmann's Lehrbuch der Unorganischen Chemie. These weights differ from those hitherto accepted and are generally lighter than those given in earlier textbooks. It is interesting to note that our counting endorses the earlier numbers, for the most part, and we must wait to see if later observations will endorse the last results of orthodox chemistry or confirm ours. Hydrogen 18, 1 ones. Helium 43, 94. Lithium 7, 66, 98. Beryllium 9, 11, 9, ones. Boron 211, 11, 10, 86. Carbon 216, 12, 11, 91. Nitrogen 261, 14, 50, 14, 1. Oxygen 290, 16, 11, 15, 879. Fluorine 340, 18, 88, 18, 90. Neon 360, 2019, 9. Sodium 23, 22, 22, 88. Magnesium 24, 24, 18. Aluminium 27, 26, 91. Silicon 520, 28, 88, 28, 18. Phosphorus 558, 31, 30, 77. Sulfur 576, 32, 31, 82. Chlorine 639, 35, 50, 35, 473. Potassium 38, 944, 38, 85. Argon 714, 39, 66, 39, 60. Calcium 40, 39, 74. Scandium 44, 43, 78. Titanium 48, 47, 74. Vanadium 51, 50, 84. Chromium 52, 51, 74. Manganese 992, 55, 1154, 57. Iron 1008, 56, 55, 47. Cobalt 1036, 57, 55, 57, 7. Nic 59, 30. Copper 1139, 63, 277, 63, 12. Zinn 65, 64, 91. Gallium 70, 69, 50. Germanium 72, 22, 71, 93. Arsen 75, 74, 45. Selenium 79, 78, 58. Bromine 1439, 79, 944, 79, 953. Krypton 1464, 81, 33, 81, 20. Rubidium 85, 84, 85. Strontium 87, 1186, 95. Yttrium 89, 2288, 34. Zirconium 90, 2289, 85. Niobium 95, 5093, 25. Molybdenum 97, 95, 26. Ruthenium 102, 66, 100, 91. Rhodium 104, 22, 102, 23. Palladium 105, 77, 105, 74. Silver 1945, 108, 55, 107, 93. Cadmium 112, 111, 60. Indium 114, 114, 5. Tin 2000, 124, 118, 118, 10. Antimony 2169 120, 50 119, 34. Tellurium 123, 50 126, 64. Iodine 2280 7 127, 55 126, 1. Xenon 2298 127, 66 127, 10. Osmium 190, 55 189, 55. Iridium 192, 11 191, 56. Platinum A 3480, 6 193, 66 193, 34. Go 197, 195, 74. Plate Roman 2, ultimate physical atoms. Plate Roman 2, male left and female right. As the words ultimate physical atom must frequently occur, it is necessary to state what we mean by the phrase. Any gaseous chemical atom may be dissociated into less complicated bodies, these again into still less complicated, these again into yet still less complicated. These will be dealt with presently. After the third dissociation, but one more is possible. The fourth dissociation gives the ultimate physical atom. This may vanish from the physical plane, but it can undergo no further dissociation on it. In this ultimate state of physical matter, two types of atoms have been observed. They are alike in everything save the direction of their whorls and of the force which pours through them. In the one case, force pours in from the outside, from fourth-dimensional space, and passing through the atom, pours into the physical world. In the second, it pours in from the physical world and out through the atom into the outside again, i.e. vanishes from the physical world. The one is like a spring, from which water bubbles out. The other is like a hole, into which water disappears. We call the atoms from which force comes out positive or male, those through which it disappears negative or female. All atoms, so far as observed, are of one or other of these two forms. Plate Roman 2. It will be seen that the atom is a sphere, slightly flattened, and there is a depression at the point where the force flows in, causing a heart-like form. Each atom is surrounded by a field, formed of the atoms of the four higher planes, which surround and interpenetrate it. The atom can scarcely be said to be a thing, though it is the material out of which all things physical are composed. It is formed by the flow of the life force and vanishes with its ebb. When this force arises in space, the apparent void which must be filled with substance of some kind, of inconceivable tenuity, atoms appear. If this be artificially stopped for a single atom, the atom disappears, there is nothing left. Presumably, were that flow checked but for an instant, the whole physical world would vanish, as a cloud melts away in the Empyrean. It is only the persistence of that flow which maintains the physical basis of the universe. In order to examine the construction of the atom, a space is artificially made. Then, if an opening be made in the wall thus constructed, the surrounding force flows in, and three walls immediately appear, surrounding the whole with their triple spiral of 2.5 coils, and returning to their origin by a spiral within the atom. These are at once followed by 7 finer walls, which following the spiral of the first 3 on the outer surface, and returning to their origin by spiral within that, flowing in the opposite direction, form a caduceus with the first 3. Each of the 3 coarser walls, flattened out, makes a closed circle. Each of the 7 finer ones, similarly flattened out, makes a closed circle. The forces which flow in them again come from outside, from a fourth-dimensional space. Each of the finer walls is formed of 7 yet finer ones, set successively at right angles to each other, each finer than its predecessor. These we call spiral A. It will be understood from the foregoing that the atom cannot be said to have a wall of its own, unless these walls of force can be so designated. Its wall is the pressed-back space. As said in 1895, of the chemical atom, the force clears itself a space, pressing back the undifferentiated matter of the plane and making to itself a whirling wall of this matter. The wall belongs to space, not to the atom. In the 3 walls flow currents of different electricities. The 7 vibrate in response to etheric waves of all kinds, to sound, light, heat, etc. They show the 7 colors of the spectrum, give out the 7 sounds of the natural scale, respond in a variety of ways to physical vibration, flashing, singing, pulsing bodies, They move incessantly, inconceivably beautiful and brilliant. The atom has, as observed so far, three proper motions, i.e., motions of its own, independent of any imposed upon it from outside. It turns incessantly upon its own axis, spinning like a top. It describes a small circle with its axis, as though the axis of the spinning top moved in a small circle. It has a regular pulsation, a contraction and expansion, like the pulsation of the heart. When a force is brought to bear upon it, it dances up and down, flings itself wildly from side to side, performs the most astonishing and rapid gyrations, but the three fundamental motions incessantly persist. If it be made to vibrate, as a whole, at the rate which gives any one of the 7 colors, the wall belonging to that color glows out brilliantly. Arrangement of atoms in an electric current. An electric current brought to bear upon the atoms checks their proper motions, i.e., renders them slower. The atoms exposed to it arrange themselves in parallel lines, and in each line the heart-shaped depression receives the flow, which passes out through the apex into the depression of the next, and so on. The atoms always set themselves to the current. The well-known division of diamagnetic and paramagnetic depends generally on this fact, or on an analogous action on molecules, as may be seen in the accompanying diagrams. Two atoms, positive and negative, brought near to each other, attract each other, and then commence to revolve round each other, forming a relatively stable duality. Such a molecule is neutral. Combinations of 3 or more atoms are positive, negative, or neutral, according to the internal molecular arrangement. The neutral are relatively stable. The positive and negative are continually in search of their respective opposites, with a view to establishing a relatively permanent union. 3 states of matter exist between the atomic state and the gaseous, the state in which the chemical atoms are found, the recognized chemical elements. For our purposes, we may ignore the liquid and solid states. For the sake of clearness and brevity in description, we have been obliged to name these states. We call the atomic state of the chemist elemental, the state which results from breaking up chemical elements, proto-elemental, the next higher, meta-proto-elemental, the next higher, hyper-meta-proto-elemental, then comes the atomic state. These are briefly marked as L, proto, meta, and hyper. The simplest unions of atoms, never, apparently consisting of more than 7, form the first molecular state of physical matter. Types of hyper-meta-proto-elemental matter. Types of hyper-meta-proto-elemental matter. Here are some characteristic combinations of the hyperstate. The atom is conventional, with the depression emphasized. The lines, always entering at the depression and coming out at the apex, show the resultance of lines of force. Where no line appears entering the depression, the force wells up from fourth-dimensional space. Where no line appears leaving the apex, the force disappears into fourth-dimensional space. Where the point of entry and departure is outside the atoms, it is indicated by a dot. The molecules show all kinds of possible combinations. The combinations spin, turn head over heels, and gyrate in endless ways. Each aggregation is surrounded with an apparent cell wall, the circle or oval, due to the pressure on the surrounding matter caused by its whirling motion. They strike on each other and rebound, dart hither and thither, for reasons we have not distinguished. Types of meta-proto-elemental matter. Types of meta-proto-elemental matter. The metastate, in some of its combinations, appears at first sight to repeat those of the hyperstate. The only obvious way of distinguishing to which some of the molecules of less complexity belong is to pull them out of the cell wall. If they are hypermolecules, they at once fly off as separate atoms. If they are metamolecules, they break up into 2 or more molecules containing a smaller number of atoms. Thus, one of the metamolecules of iron, containing 7 atoms, is identical in appearance with a hyperheptad, but the latter dissociates into 7 atoms, the former into 2 triads and a single atom. Long-continued research into the detailed play of forces and their results is necessary. We are here only able to give preliminary facts, and details are opening up the way. The following may serve as characteristic metatypes. These are taken from constituents of the various elements: 1 from Gl, 2 and from Fe, 4 from Bo, 5, 6 and from 100, 8 from He, 9 from Fl, 10, 11, 12 from Li, 13 and from Na. Others will be seen in the course of breaking up the elements. The proto-state preserves many of the forms in the elements, modified by release from the pressure to which they are subjected in the chemical atom. In this state, various groups are thus recognizable, which are characteristic of allied metals. Types of proto-elemental matter. Types of proto-elemental matter. These are taken from the products of the first disintegration of the chemical atom by forcibly removing it from its whole. The groups fly apart, assuming a great variety of forms, often more or less geometrical. The lines between the constituents of the groups, where indicated, no longer represent lines of force, but are intended to represent the impression of form, i.e., of the relative position and motion of the constituents made on the mind of the observer. They are elusive, for there are no lines, but the appearance of lines is caused by the rapid motion of the constituents up and down, or along them backwards and forwards. The dots represent atoms or groups of atoms within the proto-elements. 1 is found in 100, 2 in He, 4 in Fl, 5 in Li, 6 in N, 7 in Ru, 8 in Na, 9 in Co, 11 in Phi, 12 in C. We shall return to these when analyzing the elements and shall meet many other proto-elemental groupings. The first thing which is noticed by the observer, when he turns his attention to the chemical atoms, is that they show certain definite forms, and that within these forms, modified in various ways, subgroupings are observable which recur in connection with the same modified form. The main types are not very numerous, and we found that, when we arranged the atoms we had observed, according to their external forms, they fell into natural classes. When these, in turn, were compared with Sir William Crookes' classification, they proved to be singularly alike. Here is his arrangement of the elements, as it appeared in the Proceedings of the Royal Society in a paper read on June 9, 1898. Sir William Crookes' classification. This is to be read, following the lines of the figures of 8, H, He, Li, GLB, 100, N, and so on, each successive element being heavier than the one preceding it in order. The discs which fall immediately below each other form a class, thus H, Cl, Br, I. These resemble each other in various ways, and as we shall presently see, the same forms and groupings reappear. Another chart, taken from Erdmann's Lehrbuch, arranges the elements on a curved line, which curiously resembles the curves within the shell of a nautilus. The radiating lines show the classes, the whole diameter building up a family. It will be observed that there is an empty radius between hydrogen and helium, and we have placed occultum there. On the opposite radius, iron, rubidium, and osmium are seen. Chart taken from Erdmann's Lehrbuch. The external forms may be classified as follows. The internal details will be dealt with later. Plate Roman 3, plate the dumbbell. The characteristics of this are a higher and lower group, each showing 12 projecting funnels, grouped round a central body and a connecting rod. It appears in sodium, copper, silver, and gold is given 1 on plate Roman 3 as the most extremely modified example of this form. The 12 almond-like projections, above and below, are severally contained in shadowy funnels, impossible to reproduce in the drawing. The central globe contains 3 globes, and the connecting portion has swollen out into an egg, with a very complicated central arrangement. The dumbbell appears also in chlorine, bromine, and iodine, but there is no trace of it in hydrogen, the head of the group. We have not met it elsewhere. It may be remarked that in Sir William Crookes' scheme, in which they are all classed as monads, these 2 groups are the nearest to the neutral line, on the ingoing and outgoing series, and are respectively positive and negative. Chapter 2 and Ea, the tetrahedron. The characteristics of this form are 4 funnels containing ovoid bodies opening on the face of a tetrahedron. The funnels generally, but not always, radiate from a central globe. We give beryllium glucinum as the simplest example 2 on plate Roman 3, and to this group belong calcium and strontium. The tetrahedron is the form of chromium and molybdenum, but not that of the head of their group, oxygen, which is, like hydrogen, sui generis. These 2 groups are marked in orthodox chemistry as respectively positive and negative, and are closely allied. Another pair of groups show the same tetrahedral form: magnesium, zinc, and cadmium, positive, sulfur, selenium, and tellurium, negative. Selenium is a peculiarly beautiful element, with a star floating across the mouth of each funnel. This star is extremely sensitive to light, and its rays tremble violently and bend if a beam of light falls on it. All these are dyads. The tetrahedron is not confined to the external form of the above atoms. It seems to be one of the favorite forms of nature, and repeatedly appears in the internal arrangements. There is one tetrahedron within the unknown element occultum. 2 appear in helium, 3 on plate Roman 3. Yttrium has also 2 within its cube, as has germanium. 5 intersecting are found in neon, metaneon, argon, metagon, krypton, metacrypton, xenon, metaxenon, chalon, metachalon, tin, titanium, and zirconium. Gold contains no less than 20 tetrahedra. Chapter 3. The Cube. The cube appears to be the form of triads. It has 6 funnels containing ovoids and opening on the faces of the cube. Boron is chosen as an example, 4 on plate Roman 3. Its group members, scandium and yttrium, have the same form. We have not examined the 4th. The group is positive. Its negative complement consists of nitrogen, vanadium, and niobium, and we have again to note that nitrogen, like hydrogen and oxygen, departs from its group type. 2 other triad groups, the positive aluminum, gallium, and indium, the 4th unexamined, and the negative phosphorus, arsenic, and antimony, the 4th unexamined, have also 6 funnels opening on the faces of a cube. Roman 4, the octahedron. The simplest example of this is carbon, 5 on plate Roman 3. We have again the funnel with its ovoids, but now there are 8 funnels opening on the 8 faces of the octahedron. In titanium, 6 on plate Roman 3, the form is masked by the protruding arms, which give the appearance of the old Rosicrucian cross and rose, but when we look into the details later, the carbon type comes out clearly. Zirconium is exactly like titanium in form, but contains a large number of atoms. We did not examine the remaining 2 members of this group. The group is tetratomic and positive. Its negative pendant shows the same form in silicon, germanium, and tin. Again, the 4th was unexamined. Plate Roman 4, plate Roman 4. V. The bars. These characterize a set of closely allied groups, termed interperiodic. 14 bars or 7 crossed radiate from a center, as in iron 1 on plate Roman 4, and the members of each group iron, nickel, cobalt, ruthenium, rhodium, palladium, osmium, iridium, platinum, differ from each other by the weight of each bar, increasing in orderly succession. The details will be given later. Manganese is often grouped with iron, nickel, and cobalt, see Crookes lemniscates, but its 14 protruding bodies repeat the lithium spike, proto-element 5, and are grouped round a central ovoid. This would appear to connect it with lithium 2 on plate Roman 4 rather than with fluorine 3 in plate Roman 4, with which it is often classed. The lithium spike reappears in potassium and rubidium. These details, again, will come out more clearly later. Chapter 6. The star. A flat star with 5 interpenetrating tetrahedra in the center is the characteristic of neon and its allies, 4 on plate Roman 4, leaving apart helium, which, as may be seen by referring to 3, plate Roman 4, has an entirely different form. There are thus 6 clearly defined forms, typical of classes, with 2 lithium and fluorine of doubtful affinities. It is worthy of notice that in diatomic elements, 4 funnels open on the faces of tetrahedra. In triatomic, 6 funnels on the faces of cubes. In tetratomic, 8 funnels on the faces of octahedra. Thus, we have a regular sequence of the Platonic solids, and the question suggests itself: will further evolution develop elements shaped to the dodecahedron and the icosahedron? Chapter 2. We now pass from the consideration of the outer forms of the chemical elements to a study of their internal structure, the arrangement within the element of more or less complicated groups, proto-elements, capable of separate, independent existence. These, once more, may be dissociated into yet simpler groups, hypermeta proto-elements, equally capable of separate, independent existence, and resolvable into single ultimate physical atoms, the irreducible substratum of the physical world. See Theosophist, 1908, pp. 354-356. We shall have to study the general internal structure, and then the breaking up of each element, and the admirable diagrams patiently worked out by Mr. Jinnarajadasa, will make the study comparatively easy to carry on. The diagrams, of course, can only give a very general idea of the facts they represent. They give groupings and show relations, but much effort of the imagination is needed to transform the two-dimensional diagram into the three-dimensional object. The wise student will try to visualize the figure from the diagram. Thus, the two triangles of hydrogen are not in one plane. The circles are spheres, and the atoms within them, while preserving to each other their relative positions, are in swift movement in three-dimensional space. Where 5 atoms are seen, as in bromine and iodine, they are generally arranged with the central atom above the 4, and their motion indicates lines which erect 4-plane triangles, meeting at their apices on a square base, forming a square-based 4-sided pyramid. Each dot represents a single ultimate atom. The enclosing lines indicate the impression of form made on the observer and the groupings of the atoms. The groups will divide along these lines when the element is broken up, so that the lines have significance, but they do not exist as stable walls or enclosing films, but rather mark limits, not lines, of vibrations. It should be noted that it is not possible to show 5 of the prisms in the 5 intersecting tetrahedra of prisms, and atoms must therefore be added in counting. The diagrams are not drawn to scale, as such drawing would be impossible. The dot representing the atom is enormously too large compared with the enclosures, which are absurdly too small. A scale drawing would mean an almost invisible dot on a sheet of many yards square. The use of the words positive and negative needs to be guarded by the following paragraphs from the article on chemistry in the Encyclopaedia Britannica. We use the words in their ordinary textbook meaning and have not so far detected any characteristics whereby an element can be declared at sight to be either positive or negative. When binary compounds, or compounds of 2 elements, are decomposed by an electric current, the 2 elements make their appearance at opposite poles. These elements which are disengaged at the negative pole are termed electropositive or bacillus elements, while those disengaged at the positive pole are termed electronegative or chlorous elements. But the difference between these 2 classes of elements is one of degree only, and they gradually merge into each other. Moreover, the electric relations of elements are not absolute, but vary according to the state of combination in which they exist, so that it is just as impossible to divide the elements into 2 classes according to this property as it is to separate them into 2 distinct classes of metals and nonmetals. We follow here the grouping according to external forms, and the student should compare it with the groups marked in the lemniscate arrangement shown in Article Roman II, p. 377, properly p. 437, February, reading the group by the discs that fall below each other. Thus the first group is HCl, Br, hydrogen, chlorine, bromine, iodine, and a blank for an undiscovered element. The elements grow denser in descending order. Thus hydrogen is an invisible gas, chlorine a denser gas visible by its color, bromine is a liquid, iodine is a solid, all, of course, when temperature and pressure are normal. By the lowering of temperature and the increase of pressure, an element which is normally gaseous becomes a liquid, and then a solid. Solid, liquid, gaseous are 3 interchangeable states of matter, and an element does not alter its constitution by changing its state. So far as a chemical atom is concerned, it matters not whether it be drawn for investigation from a solid, a liquid, or a gas, but the internal arrangements of the atoms become much more complicated as they become denser and denser, as is seen by the complex arrangements necessitated by the presence of the 3546 ultimate atoms contained in the chemical atom of gold, as compared with the simple arrangement of the 18 ultimate atoms of hydrogen. According to the lemniscate arrangement, we should commence with hydrogen as the head of the first negative group, but as it differs wholly from those placed with it, it is better to take it by itself. Hydrogen is the lightest of the known elements, and is therefore taken as one in ordinary chemistry, and all atomic weights are multiples of this. We take it as 18 because it contains 18 ultimate atoms, the smallest number we have found in a chemical element. So our number weights are obtained by dividing the total number of atoms in an element by 18, cp. 349, January. Plate V hydrogen, plate 5, 1. Hydrogen not only stands apart from its reputed group by not having the characteristic dumbbell shape, well shown in sodium, plate I, opposite P349 January, but it also stands apart in being positive, serving as a base, not as a chlorous or acid radical, thus playing the part of a metal, as in hydrogen chloride, hydrochloric acid, hydrogen sulfate, sulfuric acid, etc. It is most curious that hydrogen, oxygen, and nitrogen, the most widely spread gases, all differ fundamentally in form from the groups they reputedly head. Hydrogen was the first chemical element examined by us nearly 13 years ago, and I reproduce here the substance of what I wrote in November 1895, for we have nothing to add to nor amend in it. Hydrogen consists of 6 small bodies, contained in an egg-like form. The outer forms are not given in the diagrams. The 6 little bodies are arranged in 2 sets of 3, forming 2 triangles which are not interchangeable, but are related to each other as object and image. The 6 bodies are not all alike. They each contain 3 ultimate physical atoms, but in 4 of the bodies, the 3 atoms are arranged in a triangle, and in the remaining 2 in a line. Hydrogen, 6 bodies of 318. Atomic weight 1. Number weight 18, 1. I. The dumbbell group. Ia. This group consists of Cl, Br, and I, chlorine, bromine, and iodine. They are monads, diamagnetic and negative. Chlorine plate 5, 2. As already said, the general form is that of the dumbbell, the lower and upper parts each consisting of 12 funnels, 6 sloping upwards and 6 downwards, the funnels radiating outwards from a central globe, and these 2 parts being united by a connecting rod, C, again, sodium, plate I. The funnel shown flat as an isosceles triangle, standing on its apex, is a somewhat complicated structure of the same type as that in sodium, plate Roman 6, 2, the difference consisting in the addition of 1 more globe containing 9 additional atoms. The central globe is the same as in sodium, but the connecting rod differs. We have here a regular arrangement of 5 globes containing 3, 4, 5, 4, 3 atoms respectively, whereas sodium has only 3 bodies containing 4, 6, 4. But copper and silver, its congeners, have their connecting rods of exactly the same pattern as the chlorine rod, and the chlorine rod reappears in both bromine and iodine. These close similarities point to some real relation between these groups of elements, which are placed in the lemniscates equidistant from the central line, though one is on the swing, which is going towards that line, and the other is on the swing away from it. Chlorine upper part. Negative snake, 145. Total. Atomic weight 15, 87. Number weight 290, 18, 16, 11. Chromium plate Roman 8, 5, reverts to the ancestral type, the tetrahedron. The funnel is widened by the arrangement of its contents, 3 spheres forming its first ring, as compared with the units in beryllium and calcium, and the pairs in strontium and molybdenum. 2 of these spheres are identical in their contents, 2 quintets 7F, a quintet 7J, and 2 quintets 7E, E and F being to each other as object and image. The remaining sphere 7B is identical with the highest in the calcium funnel. The remaining 2 spheres, one below the other, are identical with the corresponding 2 spheres in calcium. The central globe, as regards its external segments, is again identical with that of calcium, but in the internal segments, a 6-atomed triangle, 7K, is substituted for the calcium 4-atomed one, 7E. Chromium, 4 funnels of 210 atoms, 840. Central globe, 96. Total. Atomic weight 51, 74. Number weight 936, 1852. Molybdenum plate Roman 8, 6, very closely resembles strontium, differing from it only in the composition of the highest pair of spheres in the funnels and in the presence of a little sphere containing 2 atoms only in the middle of the central globe. The topmost spheres contain no less than 8 subsidiary spheres within each. The highest of these, 7E, has 4 atoms in it. The next three have 4, 7 and 4, 7 EGE, respectively. The next three are all septets, 7G, and the last has 4, making in all for these two spheres 88 atoms, as against the 48 in corresponding spheres of strontium, making a difference of 160 in the 4 funnels. Molybdenum, 4 funnels of 408 atoms, 1,632. Central globe, 98. Total. Atomic weight, 95, 26. Number weight, 96, 11. Chapter 2. A. This group contains magnesium, zinc, cadmium, and mercury, with an empty disk between cadmium and mercury. We did not examine mercury. All are diatomic, diamagnetic, and positive. The corresponding group consists of sulfur, selenium, and tellurium, also all diatomic and diamagnetic, but negative. The same characteristics of 4 funnels opening on the faces of a tetrahedron are found in all, but magnesium and sulfur have no central globe, and in cadmium and tellurium, the globe has become a cross. Plate Roman 9, Plate Roman 9. Magnesium, Plate Roman 9-1 introduces us to a new arrangement. Each group of 3 ovoids forms a ring, and the 3 rings are within a funnel. At first glance, there are 3 bodies in the funnel. On examination, each of these is seen to consist of 3, with other bodies, spheres, again within them. Apart from this, the composition is simple enough, all the ovoids being alike, and composed of a triplet, a septet, and a duad. Magnesium, 4 funnels of 108 atoms, 432. Atomic weight, 24, 18. Number weight, 432, 1824. Zinc, Plate Roman 9-2, also brings a new device. The funnel is of the same type as that of magnesium, while septets are substituted for the triplets, and additional atoms are thus slipped in. Then we see 4 spikes, alternating with the funnels and pointing to the angles, each adding 144 atoms to the total. The spikes show the 10-atom triangle, already met within other metals, 3 very regular pillars, each with 6 spheres, containing 2, 3, 4, 4, 3, 2 atoms respectively. The supporting spheres are on the model of the central globe, but contain more atoms. Funnels and spikes alike radiate from a simple central globe, in which 5 contained spheres are arranged crosswise, preparing for the fully developed cross of cadmium. The ends of the cross touch the bottoms of the funnels. Zinc, 4 funnels of 144 atoms, 576. 4 spikes of 144 atoms, 576. Central globe, 18. Total. Atomic weight, 64, 91. Number weight, 1170, 1865. Cadmium, Plate Roman 9-3, has an increased complexity of funnels. The diagram shows one of the 3 similar segments which lie within the funnels as cylinders. Each of these contains 4 spheres, 3 pillars, and 3 ovoids, like the spike of zinc turned upside down, and the zinc 10-atom triangle changed into 3 10-atomed ovoids. The centerpiece is a new form, though prefigured in the central globe of zinc. Cadmium, 3 segments of 164 atoms, equals 492. 4 funnels of 492 atoms, 1968. Central body, 48. Total. Atomic weight, 111, 60. Number weight, 2016, 18112. The corresponding negative group is headed by Plate X sulfur, Plate 10-1, which, like magnesium, has no central globe and consists simply of the zinc funnels, much less compressed than zinc, but the same in composition. Sulfur, 4 funnels of 144 atoms, 576. Atomic weight, 31, 82. Number weight, 576, 1832. Selenium, Plate 10-2, is distinguished by the exquisite peculiarity, already noticed, of a quivering star, floating across the mouth of each funnel and dancing violently when a ray of light falls upon it. It is known that the conductivity of selenium varies with the intensity of the light falling upon it, and it may be that the star is in some way connected with its conductivity. It will be seen that the star is a very complicated body, and in each of its 6 points, the 2 5-atomed spheres revolve round the 7-atomed cone. The bodies in the funnels resemble those in magnesium, but a reversed image of the top one is interposed between itself and the small duad, and each pair has its own enclosure. The central globe is the same as that of zinc. Selenium, 4 funnels of 198 atoms, 792. 4 stars of 153 atoms, 612. Central globe, 18. Total. Atomic weight, 78, 58. Number weight, 1422, 1879. Tellurium plate 10-3, it will be seen, closely resembles cadmium and has 3 cylindrical segments, of which one is figured making up the funnel. The contained bodies in the pillars run 3, 4, 5, 4, 3, 2 instead of starting with 2, and a quartet replaces a duad in the globes above. The central cross only differs from that of cadmium in having a 7-atomed instead of a 4-atomed center, so close a similarity is striking. Tellurium, 3 segments of 181 atoms equals 543. 4 funnels of 543 atoms, 2,172. Central body, 51. Total. Atomic weight, 126, 64. Number weight, 22, 23, 18, 123, 50. 5. We must now consider the ways in which the members of the tetrahedral groups break up, and as we proceed with this study, we shall find how continual are the repetitions, and how nature, with a limited number of fundamental methods, creates by varied combinations her infinite variety of forms. Beryllium, plate Roman 3-2 and Roman 8-1. Dissociation of beryllium and calcium. Beryllium offers us 4 similar funnels and a central globe, and the proto-elements consist of these 5 bodies set free. The funnel, released from pressure, assumes a spherical form, with its 4 ovoids spinning within it, and the central globe remains a sphere, containing a whirling cross. On the meta level, the ovoids are set free, and 2 from each funnel are seen to be positive, 2 negative, 16 bodies in all, plus the cross, in which the resultant force lines are changed, preparatory to its breaking into 2 duads on the hyper level. On that level, the decades disintegrate into 2 triplets and a quartet, the positive with the depressions inward, the negative with the depressions outward. Calcium, plate Roman 8-2. The funnels, as usual, assume a spherical form on the proto-level and show, in each case, 3 spheres containing ovoids. These spheres, still on the proto-level, break free from their containing funnel, as in the case of gold, P49, 12 bodies being thus liberated, while the central globe breaks up into 8 segments, each of which becomes globular and contains within it a cigar and a somewhat heart-shaped body. 4 spheres, each containing 7 10-atomed ovoids, are identical with those in beryllium and can be followed in its diagram. 8 spheres, each containing 5 9-atomed ovoids of a different type, set free, on the meta level, 80 duads, 40 positive and 40 negative, and 40 quintets, which are identical with those in chlorine. On the hyper level, the duads become single atoms within a sphere, and the central atom from the quintet is also set free, 120 in all. The remaining 4 atoms of the quintet divide into 2 duads. The central globe, dividing into 8, becomes 8 6-atomed spheres on the meta, the cigar behaving as usual, 4 cigars being positive and 4 negative, and becoming dissociated into triplets. The 4 atoms within the heart-shaped body appear as a tetrahedron, remain together on the meta level, and break up into duads on the hyper. Strontium, plate Roman 8-3. The third member of this group repeats the groups of beryllium and the B groups of calcium, and they dissociate into the bodies already described under these respectively. The 2 upper globes in each funnel repeat each other, but each globe contains 4 smaller spheres showing 3 varieties of forms. The 2 marked G, which are repeated in the central globe as H, are 7-atomed and appear as spheres or ovoids according to pressure. They are figured on P. 48 under iodine. E and F are related as object and image, and we have already seen them in copper pp. 38, and in each case, as in copper, they unite into a 10-atomed figure. On the meta level, the pair of fours form a ring, and the remaining 2 atoms form a duad, I which repeats F makes a ring with the 5th in the center, as in the 5-atomed B of calcium, as shown above. There is thus nothing new in strontium, but only repetitions of forms already studied. Oxygen, plate Roman 8, 4. Dissociation of oxygen, chromium, and molybdenum. The disintegration of oxygen, as given in 1895, may be repeated here, and the better presentation given on P54 renders it easier to follow the process. On the proto-level, the 2 snakes divide. The brilliant discs are 7-atomed, but are differently arranged, the positive snake having the atoms arranged as in the iodine ovoids, whereas the negative snake has them arranged as in a capital H. The snakes show the same extraordinary activity on the proto-level as on the gaseous, twisting and writhing, darting and coiling. The body of the snake is of 2-atomed beads, positive and negative. On the meta-level, the snakes break into 10 fragments, each consisting of a disc, with 6 beads on one side and 5 on the other, remaining as lively as the original snake. They shiver into their constituent discs and beads on the hyper-level, they're yielding the 10 discs, 5 positive and 5 negative, and the 110 beads, 55 positive and 55 negative. Chromium, plate Roman 8, 5. When we go on to chromium and molybdenum, we return to our familiar funnels and central globes, and the secondary spheres within the funnels, quickly set free, as before, on the proto-level, give us no new combinations in their contained spheres and ovoids. The A of beryllium, the B of calcium and strontium, and D of calcium, the E and F of strontium are all there. J in chromium is the same as the central sphere in the B ovoid. In the central globe, K is a pair of triangles as in hydrogen, consisting of only 6 atoms, which on the meta-level revolve round each other and break up into 2 duads and 2 units on the hyper. Molybdenum, plate Roman 8, 6. Molybdenum presents us with only 2 new forms, and these are merely 4-atomed tetrahedra, occurring in pairs as object and image. All the other bodies have already been analyzed. Chapter 2, A. We come now to the second great tetrahedral group, which, though very much complicated, is yet, for the most part, a repetition of familiar forms. Magnesium, plate Roman 9, 1. Dissociation of magnesium and zinc. We are still among tetrahedra, so have to do with 4 funnels, but each funnel contains 3 rings, and each ring 3 ovoids. On the proto-level, a triple dissociation takes place. For the funnels, let free the rings as large spheres, in each of which rotate 3 12-atomed ovoids, and then the ovoids break loose from the spheres, and themselves become spherical, so that we have finally 36 proto-compounds from the tetrahedron. On the meta-level, the contained bodies, a triplet, MgA, a septet, MgB, and a duad, MgC, are set free from each globe, thus yielding 108 meta-compounds. On the hyper-level, the triplet becomes a duad and a unit, the duad becomes 2 units, and the septet a triplet and a quartet. Zinc, plate Roman 9, 2. We can leave aside the funnel, for the only difference between it and the magnesium funnel is the substitution of a second septet for the triplet, and the septet is already shown in the magnesium diagram. We have, therefore, only to consider the spikes, pointing to the angles of the enclosing tetrahedron and the central globe. These are set free on the proto-level, and the spikes immediately release their contents, yielding thus 32 separate bodies. The triangular arrangement at the top of the spike is the same as occurs in copper, B on P48, and can be there followed. One of the 3 similar pillars is shown in the accompanying diagram under ZNA. The compressed long oval becomes a globe, with 6 bodies revolving within it in a rather peculiar way. The quartets turn round each other in the middle. The triplets revolve round them in a slanting ellipse. The duads do the same on an ellipse, slanting at an angle. With the first, somewhat as in gold, RNB P40, the spheres within the globes at the base of the spikes, ZNB, behave as a cross. The cross is a favorite device in the Roman Tua groups. Finally, the central globe, ZNC, follows the same cruciform line of disintegration. Cadmium, plate Roman 9-3. Dissociation of cadmium and tellurium. Cadmium follows very closely on the lines of zinc. The pillars of the zinc spike are reproduced in the rings of the cadmium funnel. The globes are also the globes of cadmium, so neither of these needs attention. We have only to consider the 3 10-atomed ovoids, which are substituted for the 1 10-atomed triangle of zinc and the central cross. The ovoids become spheres, CD a B, the contained bodies revolving within them, a whirling on a diameter of the sphere, cutting it in halves, as it were, and be whirling round it at right angles. The cross also becomes a sphere, CDC, but the cruciform type is maintained within it by the relative positions of the contained spheres in their revolution. The subsequent stages are shown in the diagram. Sulfur, plate Xi1. Sulfur has nothing new, but shows only the funnels already figured in magnesium, with the substitution of a second septet for the triplet, as in zinc. Selenium, plate 10-2. Dissociation of selenium. The funnel of selenium is a rearrangement of the 12-atomed ovoids of magnesium and the 10-atomed ovoids of cadmium. The funnels, on disintegrating, set free 12 groups, each containing 9 spheres. On the meta-level, the 10-atomed bodies are set free, and the 12-atomed divide into duads and decads, thus yielding 72 decads and 36 duads. The duads, however, at once recombine into hexads, thus giving only 12 meta-elements, or 84 in all from the funnels. The central globe holds together on the proto-level, but yields 5 meta-elements. The star also at first remains a unit on the proto-level, and then shoots off into 7 bodies, the center keeping together, and the 6 points becoming spheres, within which the 2 cones, base to base, whirl in the center, and the globes circle round them. On the meta-level, all the 30 bodies contained in the star separate from each other and go on their independent ways. Selenium offers a beautiful example of the combination of simple elements into a most exquisite whole. Tellurium, plate 10-3. Tellurium very closely resembles cadmium, and they are, therefore, placed on the same diagram. The pillars are the same as in chlorine and its congeners, with a duad added at the base. The 10-atomed ovoid is the same as in cadmium and follows the same course in breaking up. It would be interesting to know why this duad remains as a duad in selenium and breaks up into a septad and triad in the other members of the group. It may be due to the greater pressure to which it is subjected in selenium, or there may be some other reason. The cross in tellurium is identical with that in cadmium, except that the center is 7-atomed instead of 4-atomed. Chapter 6. Chapter 3 and Ea, the cube groups. We have here 4 groups to consider, all the members of which are triads and have 6 funnels opening on the 6 faces of a cube. Chapter 3. Boron, scandium, and yttrium were examined. They are all triatomic, paramagnetic, and positive. The corresponding group consists of nitrogen, vanadium, and niobium. They are triatomic, paramagnetic, and negative. We have not examined the remaining members of these groups. In these 2 groups, nitrogen dominates, and in order to make the comparison easy, the nitrogen elements are figured on both plate Xi and plate Roman 12. It will be seen that scandium and yttrium of the positive group differ only in details from vanadium and niobium of the negative group. The ground plan on which they are built is the same. We noted a similar close resemblance between the positive strontium and the negative molybdenum. Plate Xi, boron, plate Roman 3, 4, and plate Xi 1. We have here the simplest form of the cube. The funnels contain only 5 bodies, 4 6-atomed ovoids, and 1 6-atomed cigar. The central globe has but 4 5-atomed spheres. It is as simple in relation to its congeners as is beryllium to its group members. Boron, 6 funnels of 30 atoms, 180. Central globe, 20. Total. Atomic weight 10, 86. Number weight 218, 11. Scandium, plate Xi 2. For the first time we meet funnels of different types, A and B, 3 of each kind, appear to be positive and B negative, but this must be stated with reserve. In A, the boron funnel is reproduced, the cigar having risen above its companion ovoids. But the most important matter to note in respect to this funnel is our introduction to the body, marked a 110. This body was observed by us first in nitrogen in 1895, and we gave it the name of the nitrogen balloon. For in nitrogen, it takes the balloon form, which it also often assumes in other gaseous elements. Here it appears as a sphere, the form always assumed on the proto-level, and it will be seen, on reference to the detailed diagram A, to be a complicated body, consisting of 6 14-atomed globes arranged round a long ovoid containing spheres with 3, 4, 6, 6, 4, 3 atoms respectively. It will be observed that this balloon appears in every member of these two groups, except boron. The B funnel runs largely to triads, C and B, B, C4b, having not only a triadic arrangement of spheres within its contained globes, but each sphere has also a triplet of atoms. In C, C4c, there is a triadic arrangement of spheres, but each contains duods. B is completed by a 5-atomed sphere at the top of the funnel. It should be noted that a B and C all are constituents of nitrogen. The central globe repeats that of boron, with an additional 4-atomed sphere in the middle. Scandium, 3 funnels of 140 atoms, 420. 3 of 116, 348. Center globe, 24. Total. Atomic weight 43, 78. Number weight 792, 1844. Yttrium, plates I, 3. Here we have a quite new arrangement of bodies within the funnel being of one type only. 2 cigars whirl on their own axes in the center near the top, while 4 8-atomed globes, C4e, chase each other in a circle round them, spinning madly on their own axes. This axial spinning seems constant in all contained bodies all the time. Lower down in the funnel, a similar arrangement is seen, with a globe C4d, a nitrogen element, replacing the cigars, and 6-atomed ovoids replacing the globes. The nitrogen balloon occupies the 3rd place in the funnel, now showing its usual shape in combination, while the B globe, C4b, of scandium takes on a lengthened form below it. The central globe presents us with 2 tetrahedra, recalling one of the combinations in gold, see plate Roman 7d, and differing from that only by the substitution of 2 quartets for the 2 triplets in gold. One funnel of yttrium contains exactly the same number of atoms as is contained in a gaseous atom of nitrogen. Further, a B and D are all nitrogen elements. We put on record these facts without trying to draw any conclusions from them. Someday, we, or others, may find out their significance and trace through them obscure relations. Yttrium, 6 funnels of 261 atoms, 1,566. Central globe 40. Total. Atomic weight 88, 34. Number weight 1606, 1889, 22. The corresponding negative group of nitrogen, vanadium, and niobium is rendered particularly interesting by the fact that it is headed by nitrogen, which, like the air, of which it forms so large a part, pervades so many of the bodies we are studying. What is there in nitrogen which renders it so inert as to conveniently dilute the fiery oxygen and make it breathable, while it is so extraordinarily active in some of its compounds that it enters into the most powerful explosives? Some chemist of the future, perhaps, will find the secret in the arrangement of its constituent parts, which we are able only to describe. Plate Roman 12, plate Roman 12. Nitrogen, plate Roman 12, 1, does not assume the cubical form of its relatives, but is in shape like an egg. Referring again to our 1895 investigations, I quote from them. The balloon-shaped body, C4a, floats in the middle of the egg, containing 6 small spheres in 2 horizontal rows and a long ovoid in the midst. This balloon-shaped body is positive and is drawn down towards the negative body B, C4b, with its 7 contained spheres, each of which has 9 atoms within it, 3 triads. 4 spheres are seen, in addition to the 2 larger bodies, Two of these, C4d, each containing 5 smaller globes, are positive, and two, C4c, containing 4 smaller globes, are negative. Nitrogen, balloon 110. Over. 2 bodies of 20 atoms 40. 2, 24, 48. Total. Atomic weight 14, 1. Number weight 261, 18, 14, 50. Vanadium, plate Roman 12, 2, closely follows scandium, having 2 types of funnels. Funnel A only differs from that of scandium by having a globe C4d inserted in the ring of 4 ovoids. Funnel B has a 6-atomed, instead of a 5-atomed globe at the top, and slips a third globe containing 20 atoms C4d between the 2 identical with those of scandium C4c. The central globe has 7 atoms in its middle body instead of 4. In this way does vanadium succeed in overtopping scandium by 126 atoms. Vanadium, 3 funnels of 160 atoms, 480. 3, 137, 411. Central globe, 27. Total. Atomic weight 50, 84. Number weight 918, 1851. Niobium, plate Roman 12, 3, is as closely related to yttrium as is vanadium to scandium. The little globes that scamper round the cigars contain 12 atoms instead of 8 C4e. The rest of the funnel is the same. In the central globe, both the tetrahedra have cigars, and a central 9-atomed globe spins round in the center, C4f, 17 atoms being thus added. Niobium, 6 funnels of 277 atoms, 1662. Central globe, 57. Total. Atomic weight 93, 25. Number weight 17, 19, 1895, 50. Chapter 3, A. Aluminum, gallium, and indium were examined from this group. They are triatomic, diamagnetic, and positive. The corresponding group contains phosphorus, arsenic, and antimony. Bismuth also belongs to it, but was not examined. They are triatomic, diamagnetic, and negative. They have no central globes. Plate Roman 13. Plate Roman 13. Aluminum, plate Roman 13, 1, the head of the group, is as usual simple. There are 6 similar funnels, each containing 8 ovoids, below which is a globe. Aluminum, 6 funnels of 81 atoms, 486. Atomic weight 26, 91. Number weight 486, 1827. Gallium, plate Roman 13, 2, has 2 segments in every funnel. In the segment to the left, a cigar balances a globe, equally 6-atomed in that of the right, and the globes to right and left are 4-atomed as against 3-atomed. In the next row, the smaller contained globes have 6 atoms as against 4, and the cones have respectively 7 and 5. By these little additions, the left-hand funnel boasts 112 atoms as against 98. Gallium, left segment 112 atoms. Right segment 98 equals 210. 6 funnels of 210 atoms, 1260. Atomic weight 69, 50. Number weight 1260, 1870. Indium, plate Roman 13, 3, repeats the segments of gallium exactly, save in the substitution of a 16-atomed body for the 7-atomed cone of the left-hand segment, and a 14-atomed body for the 5-atomed corresponding one in gallium. But each funnel now has 3 segments instead of 2. 3 funnels out of the 6 contain 2 segments of type A and 1 of type B. The remaining 3 contain 2 of type B and 1 of type A. Indium, segment, a 121 atoms. Segment B, 107. 3 funnels of 2 and B, 3, 1047. 3, 2, B and A, 3, 1005. Total. Atomic weight 114, 5. Number weight 2052, 18114. The corresponding negative group, phosphorus, arsenic, and antimony, run on very similar lines to those we have just examined. Plate Roman 14, Plate Roman 14, Phosphorus, Plate Roman 14, 1 offers us a very curious arrangement of atoms, which will give some new forms in breaking up. 2 segments are in each funnel, in fact the only 2 of group Roman 3 which do not show this arrangement or a modification thereof are aluminum and arsenic. Phosphorus, left segment 50 atoms. Right segment 43. 6 funnels of 93 atoms, 558. Atomic weight 30, 77. Number weight 558, 1831. Arsenic plate Roman 14, 2, resembles aluminum in having 8 internal subdivisions in a funnel, and the ovoids which form the top ring are identical, save for a minute difference that in aluminum the ovoids stand the reverse way from those in arsenic. It will be noted that in the former the top and bottom triangles of atoms have the apices upwards, and the middle one has its apex downwards. In arsenic, the top and bottom ones point downwards, and the middle one upwards. Arsenic inserts 16 spheres between the ovoids and globe shown in aluminum, and thus adds no less than 144 atoms to each funnel. Arsenic, 6 funnels of 225 atoms, 1,350. Atomic weight 74, 45. Number weight 1350, 1875. Antimony plate Roman 14, 3 is a close copy of indium, and the arrangement of types A and B in the funnels is identical. In the middle rings of both A and B, a triplet is substituted for a unit at the center of the larger globe. In the lowest body of type A, the cigar has vanished and is represented by a 7-atomed crystalline form. Antimony, segment A 128 atoms. Segment B, 113 atoms. 3 funnels of 2 and B3, 1,107. 3, 2, B and A3, 1,056. Total. Atomic weight 119, 34. Number weight 120, 16. Chapter 7. Boron, plate Roman 3, 4 and plate Xi 1. Dissociation of boron and scandium. The disintegration of boron is very simple. The funnels are set free and assume the spherical form, showing a central cigar and 4 globes each containing 2 triplets. The central globe is also set free with its 4 quintets and breaks at once in 2. On the meta level, the cigar breaks up as usual and the triplets separate. On the hyper level, the cigar follows its usual course and the triplets become duods and units. The globe forms 2 quintets on the meta level, and these are resolved into triplets and duods. Scandium plate Xi 2. In funnel the cigar and the ovoids behave as in boron, but the balloon, a 110 Xi 4, escapes from the funnel as it changes to a sphere and holds together on the proto level. On the meta, it yields 6 globes each containing 7 duods, and these are all set free as duods on the hyper level. The ovoid is also set free on the meta level, becoming a sphere, and on the hyper level liberates its contained bodies as 2 triplets, 2 quartets, and 2 sextets. In funnel B there is a quintet that behaves like those in the globe of boron on escaping from the funnel, in which the bodies remain on the proto level, with the exception of B63, which escapes. On the meta level, C plate Xi 4, C assumes a tetrahedral form with 6 atoms at each point, and these hold together as sextets on the hyper level. At the meta stage, B plate Xi 4b sets free 7 9-atomed bodies, which become free triplets on the hyper. The central globe shows a cross at its center, with the 4 quintets whirling round it on the proto level. On the meta, the quintets are set free and follow the boron type, while the cross becomes a quartet on the meta level and 2 duods on the hyper. Yttrium plate Xi 3. Dissociation of scandium, continued, and yttrium. In yttrium, on the proto level, a 110 and B63 both escape from the funnel and behave as in scandium. The ovoids and cigars, set free on the meta level, behave as in boron. The central globe breaks up as in gold pp. 49 and 4 quartets being set free instead of 2 quartets and 2 triplets. We have only to consider E8 and plate Xi4. E8 is a tetrahedral arrangement of duods on the meta level, set free as duods on the hyper, is an arrangement of pairs of duods at the angles of a square-based pyramid on the meta, and again, free duods on the hyper. Nitrogen, plate Roman 12:1. Nitrogen has nothing new to show us, all its constituents having appeared in scandium and yttrium. Vanadium, plate Roman 12:2. The funnel of vanadium repeats the funnel of scandium with the addition of already studied. In the B funnel, scandium B is repeated with an addition of and a sextet for a quintet. The sextet is the C of the nitrogen balloon. The central globe follows boron, save that it has a septet for its center. This was figured in iodine P48. Niobium, plate Roman 12:3. Niobium only differs from yttrium by the introduction of triplets for duods in E. On the meta level we have therefore triplets, and on the hyper each triplet yields a duod and a unit. The only other difference is in the central globe. The tetrahedra separate as usual, but liberate 8 cigars instead of 4 with 4 quartets. The central body is simple, becoming 3 triads at the angles of a triangle on the meta level, and 3 duods and 3 units on the hyper. Aluminum, plate Roman 13:1. Dissociation of aluminum and gallium. The funnels let go the globes, but the 8 ovoids remain within them, so that 7 bodies are let loose on the proto-level. When the ovoids are set free at the meta-stage, they become spherical, and a 9-atomed body is produced, which breaks up into triangles on the hyper-level. The globe becomes a cross at the meta-stage, with 1 atom from the duods at each arm in addition to its own, and these form 4 duods on the hyper and a unit from the center. Gallium, plate Roman 13:2. In gallium, the funnel disappears on the proto-level, setting free its 2 contained segments, each of which forms a cylinder, thus yielding 12 bodies on the proto-level. On the meta, the 3 upper globes in each left-hand segment are set free and soon vanish, each liberating a cigar and 2 septets, the quartet and triad uniting. On the hyper, the quartet yields 2 duods, but the triangle persists. The second set of bodies divide on the meta level, forming a sextet and a cross with a duod at each arm. These on the hyper level divide into 2 triangles, 4 duods, and a unit. The 7-atomed cone becomes 2 triangles united by a single atom, and on the meta level, these form a ring round the unit. On the hyper, they form 3 duods and a unit. In the right-hand segment, the same policy is followed, the 4 triads becoming 2 sextets, while the central body adds a third to the number. The second ring has a quartet instead of the sextet, but otherwise breaks up, as does that of the left. The quintet at the base follows that of boron. Indium, plate Roman 13:3. The complication of 3 segments of different types in each funnel does not affect the process of breaking up, and indium needs little attention. It is exactly the same as the left-hand funnel of gallium, save for the substitution of a globe containing the familiar cigar and 2 square-based pyramids. B is the same as the right-hand funnel of gallium, except that its lowest body consists of 2 square-based pyramids and a tetrahedron. All these are familiar. Phosphorus, plate Roman 14:1. Dissociation of phosphorus and antimony. The atoms in the 6 similar spheres in the segments of the phosphorus funnel are arranged on the 8 angles of a cube, and the central one is attached to all of them. On the meta level, 5 of the 9 atoms hold together and place themselves on the angles of a square-based pyramid. The remaining 4 set themselves on the angle of a tetrahedron. They yield, on the hyper level, 2 triads, a duod, and a unit. The remaining bodies are simple and familiar. Arsenic, plate Roman 14:2. Arsenic shows the same ovoids and globe as have already been broken up in aluminum, see anti. The remaining 16 spheres form 9-atomed bodies on the meta level, all similar to those of aluminum, thus yielding 12 positive and 12 negative. The globe also yields a 9-atomed body, 25 bodies of 9. Antimony, plate Roman 14:3. Antimony follows closely in the track of gallium and indium, the upper ring of spheres being identical. In the second ring, a triplet is substituted for the unit, and this apparently throws the cross out of gear, and we have a new 11-atomed figure, which breaks up into a triplet and 2 quartets on the hyper level. The lowest 7-atomed sphere of the 3 at the base is the same as we met within copper. Chapter 8. Roman 4. The octahedral groups. These groups are at the turns of the spiral in Sir William Crookes' lemniscates, CP 28. On the one side is carbon, with below it titanium and zirconium, on the other silicon, with germanium and tin. The characteristic form is an octahedron, rounded at the angles and a little depressed between the faces in consequence of the rounding. In fact, we did not, at first, recognize it as an octahedron, and we called it the chorded bale, the nearest likeness that struck us. The members of the group are all tetrads and have 8 funnels, opening on the 8 faces of the octahedron. The first group is paramagnetic and positive. The corresponding one is diamagnetic and negative. The 2 groups are not closely allied in composition, though both titanium and tin have in common the 5 intersecting tetrahedra at their respective centers. Plate Roman 15, Plate Roman 15, Carbon Plate Roman 3, 5 and Roman 15, 1 gives us the fundamental octahedral form, which becomes so masked in titanium and zirconium. As before said, P30, the protrusion of the arms in these suggests the old Rosicrucian symbol of the cross and rose, but they show at their ends the 8 carbon funnels with their characteristic contents, and thus justify their relationship. The funnels are in pairs, one of each pair showing 3 cigars, and having as its fellow a funnel in which the middle cigar is truncated, thus loosing 1 atom. Each cigar has a leaf-like body at its base, and in the center of the octahedron is a globe containing 4 atoms, each within its own wall. These lie on the dividing lines of the faces, and each holds a pair of the funnels together. It seems as though this atom had been economically taken from the cigar to form a link. This will be more clearly seen when we come to separate the parts from each other. It will be noticed that the atoms in the leaves at the base vary in arrangement, being alternately in a line and in a triangle. Carbon, 1 pair of funnels. 4 pairs of funnels of 54 atoms, 216. Atomic weight 11, 91. Number weight 216, 1812. Titanium Plate Roman 3, 6 and Roman 15, 2 has a complete carbon atom distributed over the ends of its 4 arms, a pair of funnels with their linking atom being seen in each. Then, in each arm, comes the elaborate body shown as 3C, with its 88 atoms. A ring of 12 ovoids, 3D, each holding within itself 14 atoms, distributed among 3 contained globes, 2 quartets, and a sextet, is a new device for crowding in material. Lastly comes the central body, 4E, of 5 intersecting tetrahedra, with a cigar at each of their 20 points, of which only 15 can be shown in the diagram, and a ring of 7 atoms round an eighth, that forms the minute center of the whole. Into this elaborate body, 128 atoms are built. Titanium, 1 carbon atom. 4C of 88 atoms, 352. 12D of 14, 168. Central globe, 128. Total. Atomic weight 47, 74. Number weight 864, 1848. Zirconium Plate Roman 15, 3 has exactly the same outline as titanium. The carbon atom is similarly distributed, and the central body is identical. Only in 5C and D do we find a difference on comparing them with 4C and D. The C ovoid in zirconium shows no less than 15 secondary globes within the 5 contained in the ovoid, and these, in turn, contain altogether 69 smaller spheres, with 212 atoms within them, arranged in pairs. Triplets, quartets, quintets, a sextet, and septets. Finally, the ovoids of the ring are also made more elaborate, showing 36 atoms instead of 14. In this way, the clever builders have piled up in zirconium no less than 1624 atoms. Zirconium, 1 carbon atom. 4C of 212, atoms 848. 12D of 36, 432. Central globe 128. Total atomic weight 89, 85. Number weight 90, 22. Plate Roman 16, plate Roman 16. Silicon plate Roman 16, 1 is at the head of the group, which corresponds to carbon on the opposite turn of the lemniscate. It has the usual 8 funnels, containing 4 ovoids in a circle and a truncated cigar, but no central body of any kind. All the funnels are alike. Silicon, 8 funnels of 65 atoms, 520. Atomic weight 28, 18. Number weight 520, 18, 28, 88. Germanium plate Roman 16, 2, shows the 8 funnels, containing each 4 segments, Roman 16, 4, within which are 3 ovoids and a cigar. In this case, the funnels radiate from a central globe, formed of 2 intersecting tetrahedra, with cigars at each point enclosing a 4-atomed globe. Germanium, 8 funnels of 156 atoms, 1,248. Central globe, 52. Total atomic weight 71, 93. Number weight 1318, 72, 22. Tin plate Roman 16, 3, repeats the funnel of germanium, and the central globe we met within titanium, of 5 intersecting tetrahedra, carrying 20 cigars. The latter, however, omits the 8-atomed center of the globe that was found in titanium, and hence has 120 atoms therein instead of 128. Tin, to make room for the necessary increase of atoms, adopts the system of spikes, which we met within zinc, see plate Roman 9, 2. These spikes, like the funnels, radiate from the central globe, but are only 6 in number. The 21-atomed cone at the head of the spike we have already seen in silver, and we shall again find it in iridium and platinum. The pillars are new in detail, though not in principle, the contained globes yielding a series of a triplet, quintet, sextet, septet, sextet, quintet, triplet. Tin, 8 funnels of 156 atoms, 1,248. 6 spikes of 126, 756. Central globe, 120. Total atomic weight 118, 10. Number weight 21, 24, 18, 118. V. The bars groups. Plate Roman 17, plate Roman 17. Here, for the first time, we find ourselves a little at issue with the accepted system of chemistry. Fluorine stands at the head of a group, called the interperiodic, whereof the remaining members are see Crookes table, P28, manganese, iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. If we take all these as group 5, we find that fluorine and manganese are violently forced into company with which they have hardly any points of relationship, and that they intrude into an otherwise very harmonious group of closely similar composition. Moreover, manganese reproduces the characteristic lithium spike, and not the bars of those into whose company it is thrust, and it is thus allied with lithium, with which indeed it is almost identical. But lithium is placed by Crookes at the head of a group, the other members of which are potassium, rubidium, and caesium, the last not examined. Following these identities of composition, I think it is better to remove manganese and fluorine from their incongruous companions, and place them with lithium and its allies as 5A, the spike groups, marking, by the identity of number, similarities of arrangement which exist, and by the separation, the differences of composition. It is worthwhile noting what Sir William Crookes, in his Genesis of the Elements, remarks on the relations of the interperiodic group with its neighbors. He says, "These bodies are interperiodic because their atomic weights exclude them from the small periods into which the other elements fall, and because their chemical relations with some members of the neighboring groups show that they are probably interperiodic in the sense of being in transition stages." Group 5 in every case shows 14 bars radiating from a center as shown in iron, plate Roman 4, 1, While the form remains unchanged throughout, the increase of weight is gained by adding to the number of atoms contained in a bar. The group is made up, not of single chemical elements, as in all other cases, but of subgroups, each containing 3 elements, and the relations within each subgroup are very close. Moreover, the weights only differ by 2 atoms per bar, making a weight difference of 28 in the whole. Thus we have per bar: iron 72, palladium; nic osmium; cobalt 76, iridium; ruthenium platinum, A249; rhodium platinum, B257. It will be noticed, plate Roman 17, 3, 4, 5, that each bar has 2 sections, and that the 3 lower sections in iron, cobalt, and nickel are identical. In the upper sections, iron has a cone of 28 atoms, while cobalt and nickel have each 3 ovoids, and of these the middle ones alone differ, and that only in their upper globes, this globe being 4-atomed in cobalt and 6-atomed in nickel. The long ovoids within each bar revolve round the central axis of the bar, remaining parallel with it, while each spins on its own axis. The iron cone spins round as though impaled on the axis. Iron plate Roman 4, 1 and Roman 17, 3. 14 bars of 72 atoms, 1008. Atomic weight 55, 47. Number weight 1008, 1856. Cobalt plate Roman 17, 4. 14 bars of 74 atoms, 1036. Atomic weight 57, 70. Number weight 1036, 1857, 55. Nickel plate Roman 17, 4. 14 bars of 76 atoms, 1064. Atomic weight 58, 30. Number weight 1064, 1859, 11. The weight of cobalt, as given in Erdmann's Lehrbuch, is 58, 55, but Messrs. Parker and Sexton in Nature, August 1, 1907, give the weight, as the result of their experiments, as 57, 7. Plate Roman 18, plate Roman 18. The next subgroup, ruthenium, rhodium, and palladium, has nothing to detain us. It will be observed that each bar contains 8 segments instead of the 6 of cobalt and nickel, that ruthenium and palladium have the same number of atoms in their upper ovoids, although in ruthenium, a triplet and quartet represent the septet of palladium, and that in ruthenium and rhodium the lower ovoids are identical, though one has the order 16, 14, 16, 14, and the other 14, 16, 14, 16. One constantly asks oneself, what is the significance of these minute changes? Further investigators will probably discover the answer. Ruthenium, plate Roman 18, 1. 14 bars of 132 atoms, 1848. Atomic weight 100, 91. Number weight 1848, 18102, 66. Rhodium, plate Roman 17, 2. 14 bars of 134 atoms, 1876. Atomic weight 102, 23. Number weight 1876, 18104, 22. Palladium, Roman 18, 3. 14 bars of 136 atoms, 1904. Atomic weight 105, 74. Number weight 1904, 18105, 77. The third subgroup, osmium, iridium, and platinum, is of course more complicated in its composition, but its builders succeed in preserving the bar form, gaining the necessary increase by a multiplication of contained spheres within the ovoids. Osmium has one peculiarity. The ovoid marked a Roman 18-4 takes the place of axis in the upper half of the bar, and the 3 ovoids marked B revolve round it. In the lower half, the 4 ovoids C revolve round the central axis. In platinum, we have marked 2 forms as platinum A and platinum B, the latter having 2 4-atomed spheres, Roman 18, 6B, in the place of the 2 triplets marked A it may well be that what we have called platinum B is not a variety of platinum, but a new element, the addition of two atoms in a bar being exactly that which separates the other elements within each of the subgroups. It will be noticed that the four lower sections of the bars are identical in all the members of this subgroup, each ovoid containing 30 atoms. The upper ring of ovoids in iridium and platinum A are also identical, but for the substitution in platinum A of a quartet for a triplet in the second and third ovoids, their cones are identical, containing 21 atoms, like those of silver and tin. Osmium, plate Roman 18, 4. 14 bars of 245 atoms, 3,430. Atomic weight 189, 55. Number weight 34, 30, 18, 190, 55. Iridium, plate Roman 18, 5. 14 bars of 247 atoms, 3,458. Atomic weight 191, 11. Number weight 34, 58, 18, 192, 11. Platinum A, plate Roman 18, 6. 14 bars of 249 atoms, 3,486. Atomic weight 193, 66. Number weight 34, 86, 18, 193, 34. Platinum B, plate Roman 18, 6B. 14 bars of 251 atoms, 3,514. Atomic weight. Number weight 35, 14, 18, 195, 22. 5A, the spike groups. I place within this group lithium, potassium, rubidium, fluorine, and manganese because of their similarity in internal composition. Manganese has 14 spikes, arranged as in the iron group, but radiating from a central globe. Potassium has 9, rubidium has 16, in both cases radiating from a central globe. Lithium, plate Roman 4, 2, and fluorine, plate Roman 4, 3, are the two types which dominate the group. Lithium supplying the spike, which is reproduced in all of them, and fluorine the nitrogen balloon, which appears in all save lithium. It will be seen that the natural affinities are strongly marked. They are all monads and paramagnetic. Lithium, potassium, and rubidium are positive, while fluorine and manganese are negative. We seem thus to have a pair corresponding with each other, as in other cases, and the interperiodic group is left interperiodic and congruous within itself. Plate Roman 19, plate Roman 19. Lithium, plate Roman 4, 2, and plate Roman 19, 1 is a striking and beautiful form, with its upright cone or spike, its 8 radiating petals X at the base of the cone, and the plate-like support in the center of which is a globe, on which the spike rests. The spike revolves swiftly on its axis, carrying the petals with it. The plate revolves equally swiftly in the opposite direction. Within the spike are 2 globes and a long ovoid. The spheres within the globe revolve as a cross. Within the ovoid are 4 spheres containing atoms arranged on tetrahedra and a central sphere with an axis of 3 atoms surrounded by a spinning wheel of 6. Lithium, spike of 63 atoms, 63. 8 petals of 6 atoms, 48. Central globe of 16 atoms, 16. Total. Atomic weight 6, 98. Number weight 127, 18, 7, 5. Potassium, plate Roman 19, 2, consists of 9 radiating lithium spikes, but has not petals. Its central globe contains 134 atoms, consisting of the nitrogen balloon, encircled by 6 4-atomed spheres. Potassium, 9 bars of 63 atoms, 567. Central globe, 134. Total. Atomic weight 38, 94. Number weight 701, 1838, 85. The weight, as determined by Richards, is 39, 114. Rubidium, plate Roman 19, 3, adds an ovoid, containing 3 spheres, 2 triplets, and a sextet, to the lithium spike, of which it has 16, and its central globe is composed of 3 balloons. Rubidium, 16 spikes of 75 atoms, 1,200. Central globe, 330. Total. Atomic weight, 84, 85. Number weight, 15, 30, 18, 85. The corresponding negative group consists only of fluorine and manganese, so far as our investigations have gone. Fluorine plate Roman 4, 3, and plate Roman 17, 1, is a most peculiar-looking object like a projectile, and gives one the impression of being ready to shoot off on the smallest provocation. The 8 spikes, reversed funnels, coming to a point, are probably responsible for this warlike appearance. The remainder of the body is occupied by 2 balloons. Fluorine, 8 spikes of 15 atoms, 120. 2 balloons, 220. Total. Atomic weight, 18, 90. Number weight, 340, 18, 18, 88. Manganese, plate Roman 17, 2, has 14 spikes radiating from a central balloon. Manganese, 14 spikes of 63 atoms, 882. Central balloon, 110. Total. Atomic weight, 54, 57. Number weight, 992, 1855, 11. Chapter 9. We have now to consider the breaking up of the octahedral groups, and more, as we proceed, do we find that the most complicated arrangements are reducible to simple elements which are already familiar. Carbon, plate Roman 3, 5, and Roman 15, 1. Dissociation of carbon. Carbon is the typical octahedron, and a clear understanding of this will enable us to follow easily the constitution and disintegration of the various members of these groups. Its appearance as a chemical atom is shown on plate Roman 3 and see Roman 15, 1. On the proto-level, the chemical atom breaks up into 4 segments, each consisting of a pair of funnels connected by a single atom. This is the proto-element which appears at the end of each arm of the cross in titanium and zirconium. On the meta-level, the 5 6-atomed cigars show 2 neutral combinations, and the truncated cigar of 5 atoms is also neutral. The leaves yield 2 forms of triplet, 5 different types being thus yielded by each pair of funnels, exclusive of the linking atom. The hyperlevel has triplets, duods, and units. Titanium, plate Roman 3, 6, and Roman 15, 2, 3. Dissociation of titanium and zirconium. On the proto-level, the cross breaks up completely, setting free the pairs of funnels with the linking atom A and B. As in carbon, the 4 bodies marked C, the 12 marked D, and the central globe marked E. The latter breaks up again, setting free its 5 intersecting cigar-bearing tetrahedra, which follow their usual course, see occultum, P44. The 8-atomed body in the center makes a ring of 7 atoms round a central one, like that in occultum, see P44, diagram B, from which it only differs in having the central atom and breaks up similarly, setting the central atom free. The ovoid C sets free its 4 contained globes, and the ovoid D sets free the 3 within it. Thus, 61 proto-elements are yielded by titanium. On the meta-level, C, titanium, breaks up into star-like and cruciform bodies. The component parts of these are easily followed. On the hyper-level, of the 4 forms of triplets, one behaves as in carbon, and the others are shown, a B and F. The cruciform quintet yields a triplet and a duad C and D. The tetrahedra yield 2 triplets G and H and 2 units. The septet, a triplet K and a quartet J on the meta-level. The bodies from D behave like their equivalents in sodium. Each D shows 2 quartets and a sextet, breaking up on the hyper-level into 4 duads and 2 triads. Zirconium, plate Roman 15, 2, 5. Zirconium reproduces in its C the 4 forms that we have already followed in the corresponding C of titanium, and as these are set free on the proto-level and follow the same course on the meta and hyper levels, we need not repeat them. The central globe of zirconium C sets free its 9 contained bodies. 8 of these are similar and are figured in the diagram. It will be observed that the central body is the truncated cigar of carbon. Their behavior on the meta and hyper levels is easily followed there. The central sphere is also figured. The cigar follows its usual course, and its companions unite into a sextet and an octet. The D-ovoid liberates 5 bodies, 4 of which we have already seen in titanium as the crosses and sextet of sodium, and which are figured under titanium. The 4 quartets within the larger globe also follow a sodium model and are given again. Silicon, plate Roman 16, 1. Dissociation of silicon and tin. In silicon, the ovoids are set free from the funnels on the proto-level, and the truncated cigar, playing the part of a leaf, is also liberated. This, and the 4 cigars, which escape from their ovoids, pass along their usual course. The quintet and quartet remain together and form a 9-atomed body on the meta-level, yielding a sextet and a triplet on the hyper. Germanium, plate Roman 16, 2, 4. The central globe, with its 2 cigar-bearing tetrahedra, need not delay us. The tetrahedra are set free and follow the occultum disintegration, and the central 4 atoms is the sodium cross that we had in titanium. The ovoids, Roman 16, 4, are liberated on the proto-level, and the cigar, as usual, bursts its way through and goes along its accustomed path. The others remain linked on the meta-level and break up into 2 triangles and a quintet on the hyper. Tin, plate Roman 16, 3, 4. Here we have only the spike to consider, as the funnels are the same as in germanium, and the central globe is that of titanium, omitting the 8-atomed center. The cone of the spike we have had in silver CP 729 May, and it is set free on the proto-level. The spike, as in zinc, becomes a large sphere with the single septet in the center, the remaining 6 bodies circling round it on differing planes. They break up as shown. Tin is SN. Iron, plate Roman 4, I, and Roman 17, 3. Dissociation of iron, cobalt, and nickel. We have already dealt with the affinities of this peculiar group, and we shall see, in the disintegration, even more clearly, the close relationships which exist according to the classification which we here follow. The 14 bars of iron break asunder on the proto-level, and each sets free its contents, a cone and 3 ovoids, which as usual become spheres. The 28-atomed cone becomes a 4-sided figure, and the ovoids show crystalline contents. They break up, on the meta-level as shown in the diagram, and are all reduced to triplets and duods on the hyper-level. Cobalt, plate Roman 17, 4. The ovoids in cobalt are identical with those of iron. The higher ovoids, which replace the cone of iron, show persistently the crystalline forms so noticeable throughout this group. Nickel, plate Roman 17, 5. The 2 additional atoms in a bar, which alone separate nickel from cobalt, are seen in the upper sphere of the central ovoid. Ruthenium, plate Roman 18, 1. The lower ovoids in ruthenium are identical in composition with those of iron, cobalt, and nickel, and may be studied under iron. The upper ones only differ by the addition of a triplet. Rhodium, plate Roman 18, 2. Rhodium has a septet, which is to be seen in the C of titanium, CK in the titanium diagram, and differs only in this from its group. Palladium, plate Roman 18, 3. In palladium, this septet appears as the upper sphere in every ovoid of the upper ring. Osmium, plate Roman 18, 4. We have here no new constituents. The ovoids are set free on the proto-level and the contained globes on the meta, all being of familiar forms. The cigars, as usual, break free on the proto-level and leave their ovoid with only 4 contained spheres, which unite into 2 9-atomed bodies, as in silicon, see above. Iridium, plate Roman 18, 5. The 21-atomed cone of silver here reappears, and its proceedings may be followed under that metal C diagram P 729 May. The remaining bodies call for no remark. Platinum, plate Roman 18, 6. Again, the silver cone is with us. The remaining bodies are set free on the proto-level and their contained spheres on the meta. Lithium, plate Roman 4-2 and Roman 19-1. Dissociation of lithium. Here we have some new combinations, which recur persistently in its allies. The bodies A in plate Roman 19-1 are at the top and bottom of the ellipse. They come to right and left of it in the proto-state, and each makes a 12-atomed body on the meta-level. The 5 bodies within the ellipse, 3 monads and 2 sextets, show 2 which we have had before. D, which behaves like the quintet and quartet in silicon after their junction, and B, which we have had in iron. The 2 bodies C are a variant of the square-based pyramid, 1 atom at the apex and 2 at each of the other angles. The globe, E, is a new form, the 4 tetrahedra of the proto-level making a single 12-atomed one on the meta. The body splits up into triplets on the hyper. B and D follow their iron and silicon models. C yields 4 duods and a unit. E breaks into 4 quartets. Potassium, plate Roman 19-2. Potassium repeats the lithium spike. The central globe shows the nitrogen balloon, which we already know, and which is surrounded on the proto-level with 6 tetrahedra, which are set free on the meta and behave as in cobalt. Hence, we have nothing new. Rubidium, plate Roman 19-3. Again the lithium spike, modified slightly by the introduction of an ovoid in place of the top sphere. The forms here are somewhat unusual, and the triangles of the sextet revolve round each other on the meta-level. All the triads break up on the hyper-level into duods and units. Fluorine, plate Roman 4-3 and plate Roman 17-1. The reversed funnels of fluorine split asunder on the proto-level and are set free, the balloons also floating off independently. The funnels, as usual, become spheres, and on the meta-level set free their contained bodies, 3 quartets and a triplet from each of the 8. The balloons disintegrate in the usual way. Manganese, plate Roman 17-2. Manganese offers us nothing new, being composed of lithium spikes and nitrogen balloons. 10. Chapter 6. The Star Groups. We have now reached the last of the groups as arranged on Sir William Crookes' lemniscates, that forming the neutral column. It is headed by helium, which is sui generis. The remainder are in the form of a flat star, C plate Roman 4-4, with a center formed of 5 intersecting and cigar-bearing tetrahedra and 6 radiating arms. 10 of these have been observed, 5 pairs in which the second member differs but slightly from the first. They are neon, metaneon, argon, metagon, krypton, metacrypton, xenon, metaxenon, chalon, metachalon. The last pair and the meta forms are not yet discovered by chemists. These all show the presence of a periodic law. Taking an arm of the star in each of the 5 pairs, we find the number of atoms to be as follows: 40, 99, 224, 363, 489. 47, 106, 230, 370, 496. It will be observed that the metaform in each case shows 7 more atoms than its fellow. Plate Roman 20, plate Roman 20, helium plate Roman 3-5 and plate Roman 20, 1 shows 2 cigar-bearing tetrahedra and 2 hydrogen triangles, the tetrahedra revolving round an egg-shaped central body and the triangles spinning on their own axes while performing a similar revolution. The whole has an attractively airy appearance, as of a fairy element. Helium, 2 tetrahedra of 24 atoms 48. 2 triangles of 9 atoms 18. Central egg 6. Total. Atomic weight 3, 94. Number weight 72, 18-4. Neon plate Roman 20, 2 and has 6 arms of the pattern shown in 2, radiating from the central globe. Neon, 6 arms of 40 atoms 240. Central tetrahedra 120. Total. Atomic weight 19, 90. Number weight 360, 1820. Metaneon plate Roman 20, 3 and differs from its comrade by the insertion of an additional atom in each of the groups included in the second body within its arm, and substituting a 7-atomed group for one of the triplets in neon. Metaneon, 6 arms of 47 atoms 282. Central tetrahedra 120. Total. Atomic weight. Number weight 402, 1822, 33. Argon plate Roman 20, 4, 6 and shows within its arms the B63 which we met in nitrogen, yttrium, vanadium and niobium, but not the balloon, which we shall find with it in krypton and its congeners. Argon, 6 arms of 99 atoms, 594. Central tetrahedra, 120. Total. Atomic weight 39, 60. Number weight 714, 1839, 66. Metagon, plate Roman 20, 5, 6 and again shows only an additional 7 atoms in each arm. Metagon, 6 arms of 106 atoms, 636. Central tetrahedra, 120. Total. Atomic weight. Number weight 756, 1842. Plate Roman 21, plate Roman 21. Krypton, plate Roman 21, 1N, and plate Roman 20, 6N, contains the nitrogen balloon, elongated by its juxtaposition to be 63. The central tetrahedra appear as usual. Krypton, 6 arms of 224 atoms, 1344. Central tetrahedra, 120. Total. Atomic weight 81, 20. Number weight 1464, 1881, 33. Metacrypton differs only from krypton by the substitution of Z for Y in each arm of the star. Metacrypton, 6 arms of 231 atoms, 1386. Central tetrahedra, 120. Total. Atomic weight. Number weight 1506, 1883, 66. Xenon plate Roman 21, 2N, and plate Roman 20, 6N, has a peculiarity shared only by Calon, that X and Y are asymmetrical, the center of one having 3 atoms and the center of the other 2. Is this done in order to preserve the difference of 7 from its comrade? Xenon, 6 arms of 363 atoms, 2178. Central tetrahedra, 120. Total. Atomic weight, 127, 10. Number weight 2298, 18127, 66. Metaxenon differs from xenon only by the substitution of 2 Z's for X and Y. Metaxenon, 6 arms of 370 atoms, 2220. Central tetrahedra, 120. Total. Atomic weight. Number weight 23, 40, 18, 130. Calon plate Roman 21, 3N, and plate Roman 20, 6N, has a curious cone, possessing a kind of tail which we have not observed elsewhere. X and Y show the same asymmetry as in xenon. Calon, 6 arms of 489 atoms, 2934. Central tetrahedra, 120. Total. Atomic weight. Number weight 3054, 18169, 66. Metacalon again substitutes 2 Z's for X and Y. Metacalon, 6 arms of 496 atoms, 2976. Central tetrahedra, 120. Total. Atomic weight. Number weight 3096, 18172. Only a few atoms of calon and metacalon have been found in the air of a fair-sized room. It does not seem worthwhile to break up these elements, for their component parts are so familiar. The complicated groups, A110, B63, and have all been fully dealt with in preceding pages. There remains now only radium, of the elements which we have, so far, examined, and that will be now described, and will bring to an end this series of observations. A piece of close and detailed work of this kind, although necessarily imperfect, will have its value in the future, when science along its own lines shall have confirmed these researches. It will have been observed that our weights, obtained by counting, are almost invariably slightly in excess of the orthodox ones. It is interesting that in the latest report of the International Commission, November 13, 1907, printed in the Proceedings of the Chemical Society of London, Vol. Roman 24, number 33, and issued on January 25, 1908, the weight of hydrogen is now taken at 1.8 instead of at 1. This would slightly raise all the orthodox weights. Thus aluminum rises fro 91 to 27.1, antimony fro 34 to 120.2, and so on. Chapter 11. Radium. Plate Roman 22. Plate Roman 22. Radium has the form of a tetrahedron, and it is in the tetrahedral groups, see Article Roman 4, that we shall find its nearest congeners. Calcium, strontium, chromium, molybdenum resemble it most closely in general internal arrangements, with additions from zinc and cadmium. Radium has a complex central sphere, plate Roman 22, extraordinarily vivid and living. The whirling motion is so rapid that continued accurate observation is very difficult. The sphere is more closely compacted than the centerpiece in other elements, and is much larger in proportion to the funnels and spikes than is the case with the elements above named. Reference to plate Roman 8 will show that in these the funnels are much larger than the centers, whereas in radium the diameter of the sphere and the length of the funnel or spike are about equal. Its heart consists of a globe containing 7 atoms, which assume on the proto-level the prismatic form shown in cadmium, magnesium, and selenium. This globe is the center of 2 crosses, the arms of which show respectively 3-atomed and 2-atomed groups. Round this sphere are arranged, as on radii, 24 segments, each containing 5 bodies, 4 quintets, and a septet, and 6 loose atoms, which float horizontally across the mouth of the segment. The whole sphere has thus a kind of surface of atoms. On the proto-level, these 6 atoms in each segment gather together and form a cigar. In the rush of the streams presently to be described, one of these atoms is occasionally torn away, but is generally, if not always, replaced by the capture of another which is flung into the vacated space. Each of the 4 funnels opens, as usual, on one face of the tetrahedron, and they resemble the funnels of strontium and molybdenum, but contain 3 pillars instead of 4, plate Roman 23. They stand within the funnel as though at the angles of a triangle, not side by side. The contained bodies, though numerous, contain forms which are all familiar. The spikes alternate with the funnels and point to the angles of the tetrahedron as in zinc and cadmium. Each spike contains 3 lithium spikes. See plate Roman 19, with a 10-atomed cone or cap at the top, floating above the 3 plate Roman 24. The petals or cigars of lithium exist in the central globe in the floating atoms, and the 4-atomed groups which form the lithium plate may be seen in the funnels, so that the whole of lithium appears in radium. So much for its composition, but a very peculiar result, so far unobserved elsewhere, arises from the extraordinarily rapid whirling of the central sphere. A kind of vortex is formed, and there is a constant and powerful indraft through the funnels. By this, particles are drawn in from without, and these are swept round with the sphere, their temperature becoming much raised, and they are then violently shot out through the spikes. It is these jets which occasionally sweep away an atom from the surface of the sphere. These particles may be atoms, or they may be bodies from any of the etheric levels. In some cases, these bodies break up and form new combinations. In fact, lithium seems like a kind of vortex of creative activity, drawing in, breaking up, recombining, shooting forth, a most extraordinary element. Radium, 4 funnels of 618 atoms, 2,472. 4 spikes of 199 atoms, 796. Central sphere, 819. Total atomic weight. Number weight 4087, 18227. 5. Plate Roman 24, Plate Roman 24, Plate Roman 23, Plate Roman 23. Appendix. The Aether of Space. Much discussion has taken place, especially between physicists and chemists, over the nature of the substances with which all space must, according to scientific hypothesis, be filled. One side contends that it is infinitely thinner than the thinnest gas, absolutely frictionless and without weight. The other asserts that it is denser than the densest solid. In this substance, the ultimate atoms of matter are thought to float, like motes in a sunbeam, and light, heat, and electricity are supposed to be its vibrations. Theosophical investigators, using methods not at the disposal of physical science, have found that this hypothesis includes under one head 2 entirely different and widely separated sets of phenomena. They have been able to deal with states of matter higher than the gaseous, and have observed that it is by means of vibrations of this finer matter that light, heat, and electricity manifest themselves to us. Seeing that matter in these higher states thus performs the functions attributed to the ether of science, they have perhaps unadvisedly called these states etheric, and have thus left themselves without a convenient name for that substance which fulfills the other part of the scientific requirements. Let us for the moment name this substance koilan, since it fills what we are in the habit of calling empty space. What Mulaprakati, or mother matter, is to the inconceivable totality of universes, koilan is to our particular universe, not to our solar system merely, but to the vast unit which includes all visible suns. Between koilan and Mulaprakati there must be various stages, but we have at present no direct means of estimating their number or of knowing anything whatever about them. In an ancient occult treatise, however, we read of a colorless spiritual fluid, which exists everywhere and forms the first foundation on which our solar system is built. Outside the latter, it is found in its pristine purity only between the stars of the universe. As its substance is of a different kind from that known on Earth, the inhabitants of the latter, seeing through it, believe in their illusion and ignorance that it is empty space. There is not one finger's breadth of void space in the whole boundless universe. The mother substance is said, in this treatise, to produce this aether of space as its 7th grade of density, and all objective suns are said to have this for their substance. To any power of sight which we can bring to bear upon it, this koilan appears to be homogeneous, though it is probably nothing of the kind, since homogeneity can belong to the mother substance alone. It is out of all proportion denser than any other substance known to us, infinitely denser, if we may be pardoned the expression, so much denser that it seems to belong to another type or order of density. But now comes the startling part of the investigation. We might expect matter to be a densification of this koilan. It is nothing of the kind. Matter is not koilan, but the absence of koilan, and at first sight, matter and space appear to have changed places, and emptiness has become solidity, solidity has become emptiness. To help us to understand this clearly, let us examine the ultimate atom of the physical plane, CPP 2123. It is composed of 10 rings or wires, which lie side by side, but never touch one another. If one of these wires be taken away from the atom, and be, as it were, untwisted from its peculiar spiral shape and laid out on a flat surface, it will be seen that it is a complete circle, a tightly twisted endless coil. This coil is itself a spiral containing 1680 turns. It can be unwound, and it will then make a much larger circle. This process of unwinding may be again performed, and a still bigger circle obtained, and this can be repeated till the 7 sets of spiral A are all unwound, and we have a huge circle of the tiniest imaginable dots, like pearls threaded on an invisible string. These dots are so inconceivably small that many millions of them are needed to make one ultimate physical atom. And while the exact number is not readily ascertainable, several different lines of calculation agree in indicating it as closely approximate to the almost inconceivable total of 14,000 millions. Where figures are so huge, direct counting is obviously impossible, but fortunately, the different parts of the atom are sufficiently alike to enable us to make an estimate in which the margin of error is not likely to be very great. The atom consists of 10 wires, which divide themselves naturally into two groups, the 3 which are thicker and more prominent, and the 7 thinner ones which correspond to the colors and planets. These latter appear to be identical in constitution, though the forces flowing through them must differ, since each responds most readily to its own special set of vibrations. By actual counting, it has been discovered that the numbers of coils or spiral A of the first order in each wire is 1680, and the proportion of the different orders of spiral A to one another is equal in all cases that have been examined, and correspond with the number of dots in the ultimate spiral A of the lowest order. The ordinary sevenfold rule works quite accurately with the thinner coils, but there is a very curious variation with regard to the set of 3. As may be seen from the drawings, these are obviously thicker and more prominent, and this increase of size is produced by an augmentation, so slight as to be barely perceptible, in the proportion to one another of the different orders of spiral A and in the number of dots in the lowest. This augmentation, amounting at present to not more than 571,428 of the whole of each case, suggests the unexpected possibility that this portion of the atom may be somehow actually undergoing a change, may in fact be in process of growth, as there is reason to suppose that these 3 thicker spirals originally resembled the others. Since observation shows us that each physical atom is represented by 49 astral atoms, each astral atom by 49 mental atoms, and each mental atom by 49 of those on the Buddhic plane, we have here evidently several terms of a regular progressive series, and the natural presumption is that the series continues where we are no longer able to observe it. Further probability is lent to this assumption by the remarkable fact that if we assume one dot to be what corresponds to an atom on the 7th or highest of our planes, as is suggested in the ancient wisdom p. 42, and then suppose the law of multiplication to begin its operation, so that 49 dots shall form the atom of the next or 6th plane, 2401 that of the 5th, and so on, we find that the number indicated for the physical atom, 496, corresponds almost exactly with the calculation based upon the actual counting of the coils. Indeed, it seems probable that, but for the slight growth of the 3 thicker wires of the atom, the correspondence would have been perfect. It must be noted that a physical atom cannot be directly broken up into astral atoms. If the unit of force which whirls those millions of dots into the complicated shape of a physical atom be pressed back by an effort of will over the threshold of the astral plane, the atom disappears instantly, for the dots are released. But the same unit of force, working now upon a higher level, expresses itself not through one astral atom, but through a group of 49. If the process of pressing back the unit of force is repeated, so that it energizes upon the mental plane, we find the group there enlarged to the number of 2401 of those higher atoms. Upon the Buddhic plane, the number of atoms formed by the same amount of force is very much greater still, probably the cube of 49 instead of the square, though they have not been actually counted. Therefore, one physical atom is not composed of 49 astral or 2401 mental atoms, but corresponds to them, in the sense that the force which manifests through it would show itself on those higher planes by energizing respectively those numbers of atoms. The dots, or beads, seem to be the constituents of all matter of which we, at present, know anything. Astral, mental, and Buddhic atoms are built of them, so we may fairly regard them as fundamental units, the basis of matter. These units are all alike, spherical and absolutely simple in construction. Though they are the basis of all matter, they are not themselves matter. They are not blocks, but bubbles. They do not resemble bubbles floating in the air, which consist of a thin film of water separating the air within them from the air outside, so that the film has both an outer and an inner surface. Their analogy is rather with the bubbles that we see rising in water, before they reach the surface, bubbles which may be said to have only one surface, that of the water which is pushed back by the contained air. Just as such bubbles are not water, but are precisely the spots from which water is absent, so these units are not koilan, but the absence of koilan, the only spots where it is not, specks of nothingness floating in it, so to speak. For the interior of these space bubbles is an absolute void to the highest power of vision that we can turn upon them. That is the startling, well-nigh incredible fact. Matter is nothingness, the space obtained by pressing back an infinitely dense substance. Fohat digs holes in space of a verity, and the holes are the airy nothingnesses, the bubbles, of which solid universes are built. What are they then, these bubbles? Or rather, what is their content, the force which can blow bubbles in a substance of infinite density? The ancients called that force the breath, a graphic symbol which seems to imply that they who used it had seen the cosmic process, had seen the logos when he breathed into the waters of space, and made the bubbles which build universes. Scientists may call this force, by what names they will, names are nothing. To us, Theosophists, it is the breath of the logos. We know not whether of the logos of this solar system or of a yet mightier being. The latter would seem the more likely, since in the above-quoted occult treatise all visible suns are said to have this as their substance. The breath of the logos, then, is the force which fills these spaces, is the force which holds them open against the tremendous pressure of the koilan. They are full of his life, of himself, and everything we call matter, on however high or low a plane, is instinct with divinity. These units of force, of life, the bricks with which he builds his universe, are his very life scattered through space. Truly is it written, I established this universe with a portion of myself. And when he draws in his breath, the waters of space will close in again, and the universe will have disappeared. It is only a breath. The outbreathing which makes these bubbles is quite distinct from, and long antecedent to, the three outpourings or life waves so familiar to the theosophical student. The first life wave catches up these bubbles and whirls them into the various arrangements which we call the atoms of the several planes, and aggregates them into the molecules, and on the physical plane into the chemical elements. The worlds are built out of these voids, these emptinesses, which seem to us nothing but a divine force. It is matter made from the privation of matter. How true were H.P.B. statements in The Secret Doctrine, matter is nothing but an aggregation of atomic forces. Roman 3:398. Buddha taught that the primitive substance is eternal and unchangeable. Its vehicle is the pure luminous ether, the boundless infinite space, not a void, resulting from the absence of all forms, but on the contrary, the foundation of all forms. Roman 3:402. How vividly, how unmistakably this knowledge brings home to us the great doctrine of Maya, the transitoriness and unreality of earthly things, the utterly deceptive nature of appearances. When the candidate for initiation sees, not merely believes, remember, but actually sees, that what has always before seemed to him empty space is in reality a solid mass of inconceivable density, and that the matter which has appeared to be the one tangible and certain basis of things is not only by comparison tenuous as gossamer, the web spun by father-mother, but is actually composed of emptiness and nothingness, is itself the very negation of matter. Then for the first time he thoroughly appreciates the valuelessness of the physical senses as guides to the truth. Yet even more clearly still stands out the glorious certainty of the immanence of the divine. Not only is everything ensouled by the Logos, but even its visible manifestation is literally part of him, is built of his very substance, so that matter as well as spirit becomes sacred to the student who really understands. The koilan in which all these bubbles are formed undoubtedly represents a part, and perhaps the principal part, of what science describes as the luminiferous ether. Whether it is actually the bearer of the vibrations of light and heat through interplanetary space is as yet undetermined. It is certain that these vibrations impinge upon and are perceptible to our bodily senses only through the etheric matter of the physical plane. But this by no means proves that they are conveyed through space in the same manner, for we know very little of the extent to which the physical etheric matter exists in interplanetary and interstellar space, though the examination of meteoric matter and cosmic dust shows that at least some of it is scattered there. The scientific theory is that the ether has some quality which enables it to transmit, at a certain definite velocity, transverse waves of all lengths and intensities, that velocity being what is commonly called the speed of light, 190,000 miles per second. Quite probably, this may be true of Koilan, and if so, it must also be capable of communicating those waves to bubbles or aggregations of bubbles. And before the light can reach our eyes, there must be a downward transference from plane to plane similar to that taking place when a thought awakens emotion or causes action. In a recent pamphlet on the density of ether, Sir Oliver Lodge remarks, "Just as the ratio of mass to volume is small in the case of a solar system or a nebula or a cobweb, I have been driven to think that the observed mechanical density of matter is probably an excessively small fraction of the total density of the substance or ether contained in the space which it thus partially occupies, the substance of which it may hypothetically be held to be composed. Thus, for instance, consider a mass of platinum and assume that its atoms are composed of electrons or of some structures not wholly dissimilar. The space which these bodies actually fill, as compared with the whole space which in a sense they occupy, is comparable to 1/10,000,000th of the whole, even inside each atom, and the fraction is still smaller if it refers to the visible mass, so that a kind of minimum estimate of ethereal density on this basis would be something like 10,000 million times that of platinum." And further on he adds that this density may well turn out to be 50,000 million times that of platinum. "The densest matter known," he says, "is trivial and gossamer-like compared with the unmodified ether in the same space." Incredible as this seems to our ordinary ideas, it is undoubtedly an understatement rather than an exaggeration of the true proportion as observed in the case of Koilan. We shall understand how this can be so if we remember that Koilan seems absolutely homogeneous and solid even when examined by a power of magnification, which makes physical atoms appear in size and arrangement like cottages scattered over a lonely moor. And when we further add to this the recollection that the bubbles of which these atoms in turn are composed are themselves what may be not inaptly called fragments of nothingness. In the same pamphlet, Sir Oliver Lodge makes a very striking estimate of the intrinsic energy of the ether. He says, "The total output of a 1,000,000 kilowatt power station for 30 million years exists permanently and at present inaccessibly in every cubic millimeter of space." Here again, he is probably underestimating the stupendous truth. It may naturally be asked how, if all this be so, it is possible that we can move about freely in a solid 10,000 million times denser, as Sir Oliver Lodge says, than platinum. The obvious answer is that, where densities differ sufficiently, they can move through each other with perfect freedom. Water or air can pass through cloth, air can pass through water, an astral form passes unconsciously through a physical wall or through an ordinary human body. Many of us have seen an astral form walk through a physical, neither being conscious of the passage. It does not matter whether we say that a ghost has passed through a wall or a wall has passed through a ghost. A gnome passes freely through a rock and walks about within the earth, as comfortably as we walk about in the air. A deeper answer is that consciousness can recognize only consciousness, that since we are of the nature of the Logos, we can sense only those things which are also of his nature. These bubbles are his essence, his life, and therefore we who also are part of him can see the matter which is built of his substance, for all forms are but manifestations of him. The Koilan is to us non-manifestation, because we have not unfolded powers which enable us to cognize it, and it may be the manifestation of a loftier order of logos, utterly beyond our ken. As none of our investigators can raise his consciousness to the highest plane of our universe, the Aditattva plane, it may be of interest to explain how it is possible for them to see what may very probably be the atom of that plane. That this may be understood, it is essential to remember that the power of magnification, by means of which these experiments are conducted, is quite apart from the faculty of functioning upon one or other of the planes. The latter is the result of a slow and gradual unfoldment of the self, while the former is merely a special development of one of the many powers latent in man. All the planes around us here, just as much as any other point in space, and if a man sharpens his sight until he can see their tiniest atoms, he can make a study of them, even though he may as yet be far from the level necessary to enable him to understand and function upon the higher planes as a whole, or to come into touch with the glorious intelligences who gather those atoms into vehicles for themselves. A partial analogy may be found in the position of the astronomer with regard to the stellar universe, or let us say the Milky Way. He can observe its constituent parts and learn a good deal about them along various lines, but it is absolutely impossible for him to see it as a whole from outside, or to form any certain conception of its true shape, and to know what it really is. Suppose that the universe is, as many of the ancients thought, some inconceivably vast being. It is utterly impossible for us, here in the midst of it, to know what that being is or is doing, for that would mean raising ourselves to a height comparable with his. But we may make extensive and detailed examination of such particles of his body as happen to be within our reach, for that means only the patient use of powers and machinery already at our command. Let it not be supposed that, in thus unfolding a little more of the wonders of divine truth, by pushing our investigations to the very farthest point at present possible to us, we in any way alter or modify all that has been written in theosophical books of the shape and constitution of the physical atom, and of the wonderful and orderly arrangements by which it is grouped into the various chemical molecules. All this remains entirely unaffected. Nor is any change introduced as regards the three outpourings from the Logos, and the marvelous facility with which the matter of the various planes is by them molded into forms for the service of the evolving life. But if we wish to have a right view of the reality's underlying manifestation in this universe, we must to a considerable extent reverse the ordinary conception as to what this matter essentially is. Instead of thinking of its ultimate constituents as solid specks floating in a void, we must realize that it is the apparent void itself which is solid, and that the specks are but bubbles on it. That fact once grasped, all the rest remains as before. The relative position of what we have hitherto called matter and force is still for us the same as ever. It is only that, on closer examination, both of these conceptions prove to be variants of force, the one ensouling combinations of the other, and the real matter, koilan, is seen to be something which has hitherto been altogether outside our scheme of thought. In view of this marvelous distribution of himself in space, the familiar concept of the sacrifice of the Logos takes on a new depth and splendor. This is his dying in matter, his perpetual sacrifice, and it may be the very glory of the Logos that he can sacrifice himself to the uttermost by thus permeating and making himself one with that portion of koilan which he chooses as the field of his universe. What koilan is, what its origin, whether it is itself changed by the divine breath which is poured into it, does dark space thus become bright space at the beginning of a manifestation? These are questions to which we cannot at present even indicate answers. Perchance an intelligent study of the great scriptures of the world may yield replies.